A very warm welcome, everyone. I extend a heartfelt welcome to all of you for this engaging online session of the ATAL Faculty Development Program on Generative AI techniques, tools, and applications. It has been an incredible journey so far in our ATAL FDP on generative AI, as today we entered the day 6, the last day of this FDP, which promises yet another set of insightful discussion. From fundamental concept to real world application, we have already covered significant ground. Today, our esteemed speaker will take us further into the practical aspect and innovation shaping the field of generative AI. So let's begin by welcoming our distinguished speaker for today's session. A special welcome to our esteemed speaker, Mr. Dhiraj Madan and Mr. Mohit Jain and Dr. Abhay Gupta, who will be enlightening us with their expertise in the fascinating domain. Give them a big round of applause. With that, now I want to welcome our first keynote speaker, Mr. Dhiraj Madan. It is our privilege to have with us Mr. Dhiraj Madan. He is a researcher in machine learning and quantum algorithm at IBM Research India for more than 18 years. He has published in top conferences in ML, including Neural IPS, EMNLP, and IJCAI, and top journals including ACM Transaction of Quantum Computing. He also actively mentors students and gives talks at various universities. Prior to joining IBM, he completed bachelor's and master's in computer science from IIT Delhi with an institutive silver medal. With that, I now invite Mr. Dheeraj Madan to take over the session and share their valuable insight with us. Over to you, sir.
Thanks a lot for the nice introduction.
Sir, your voice is echoing. I think you have to mute one device mic, I guess.
Okay, is it audible now?
Yes, sir. Is it okay now?
Okay, great. Hmm. Okay, so I guess all of you can see the screen as well, right?
Yes, sir. It's visible.
Okay, yeah. Thanks a lot. I'll start today's session on diffusion models. So I just wanted to get a background of the audience. So is everyone here a faculty or there are some students also? What's the ratio?
Faculty, PhD student, and some of are the PG students.
Okay, I see. So roughly like there are 180 participants. So like how many are let's say PG students? You can raise your hands.
Mostly we have faculty members.
Mostly faculty. Okay.
Total participants are around 600.
Uh-huh.
Currently joined only. This slowly they will
Okay. So I guess yeah, so most are faculty. So today I'll actually be I won't be going that much into the practical aspects though. I'll be mostly discussing the fundamental parts as in the mathematical formulation of diffusion models. In this workshop, have there been any other talks so far related to diffusion models or generative vision algorithms? Like transformers is one thing for text. For vision, have there been any talks or specifically for diffusion? Okay, so I'll anyways not assume any background. I'll start from scratch, but I'll be going into the probabilistic formulations of diffusion models. So it will assume some like necessary mathematical background, which I guess most of the people here would be having. So yeah, so my name is Dhiraj Tan from IBM, and you can contact me at dheerajmadan1@gmail.com, and my IBM email ID is tmadan07 in.ibm.com. Okay, and in today's talk we'll be discussing mostly diffusion models and some bit of uh, mm, we will start with some bit of variational autoencoders as well. For references, you can actually look at the tutorial on diffusion models by Calvin Luo. Okay, and secondly, there are some YouTube lectures which I have created. So there is a sequence of YouTube videos which I have. I'll just put a link to that as well. So I've put a link to the YouTube playlist. You can watch it later. For now, you can bookmark it, or you can also subscribe me so that you will be able to access those videos easily after the talk. Okay. So for today's talk, the outline is going to be as follows. So firstly, we'll be starting with the ideas of generative models and variational autoencoders. Next, I'll derive the elbow or evidence lower bound. So we have time till 3:30, right? Uh, or is it till 3?
Sir, it's still 3:30. We have
3.
one and a half hour.
Okay, okay, okay.
Yes, sir.
Okay, great, great, great. So next we'll move on to evidence lower bound or elbow for VAEs. Okay, then we will define hierarchical variational autoencoders, right? And along with diffusion models, and we'll also derive an expression for the evidence lower bound for these diffusion models. And in the end, we will discuss training and inference algorithms for diffusion. Okay, so let's get started. So we'll start with generative models and a recap of VAEs. But essentially, I think we can assume that everyone is starting from scratch. So I'll not call it a recap, but it will be a very quick tour. So the idea in generative models is as follows: that given some samples, xi's, I from 1 to m, right? So these are essentially vectors where these are coming from a distribution px. Okay. So a generative model learns to model this distribution. So what do we mean when we say model the distribution? Well, essentially the idea is that given a point x, either I can, you know, compute the probability mass function at that point, or or maybe the probability density function around that point, or in other words, or the other thing it can be that we should be able to generate more samples from the distribution. So in today's talk, we when we say generative models, we what we mean is to be able to generate more samples from the distribution, right? So in general, modeling a distribution can have two meanings. One is to, given x, compute px. The other is that generate samples from px. So for today's talk, we'll be focusing on this aspect, not this aspect. Okay. So actually, both of these would mean to model the distribution, but we'll be focusing on this particular aspect. Right? So, what are some examples of generative models which you might have seen in this workshop or you might be knowing? Right. So, can you tell me maybe in the chat, or if someone wants to unmute? Do the participants have the permissions to unmute themselves? Like, I wanted to keep it more like an interactive session.
Yes, they can unmute or they can type chat box.
Yeah. Yeah, they have access, right, to the chat at least.
Can take some break after 30 minutes,
Okay, so okay, we can
but
sure
they
we
can
can
type.
take a break after 30 minutes. But simultaneously also, if you have some questions, please do keep asking over here, so that we can keep the session interactive. Okay. So let's continue. So what could be some examples of some of these generative models? So some examples includes, for example, GANs. So GANs are generative adversarial networks. Then we have VAEs, which we will just introduce now. These are variational autoencoders. Then, of course, these are diffusion models, right? So in today's session, we are going to focus on diffusion models and VAEs. Right, and of course, transformers are also there. We won't be discussing those right now. So let's get started with an algorithm for VAE, the training algorithm for VAE. So what does VAE do? Well, as we just said, it's a generative algorithm. What it means is that, so given a bunch of samples X size, I should be able to model the distribution, which means that I should be able to produce more samples from the distribution from which these points are coming from. What do these points indicate? These can indicate, for example, language, speech, vision, images, right, videos, etc. These could be anything. Typically, variational autoencoders, which we are going to discuss now, they typically focus on image data or vision data. So, firstly, the thing is that given a bunch of images or a bunch of samples X size, right, I need to learn a model. So, a model M I need to learn based on this data. And then basically based on this model, I should be able to generate more samples from the data. Right? So this is the data from which the original samples came from, but now I can generate more and more samples from the same distribution. So there are two steps over here. So this is the training phase, and this is the sampling phase. Right now, we will first discuss how to train this sort of a model. Okay, so I'll just discuss at a high level. So at a high level, training a VAE involves the following: that if you're given a data point X, right? So there is an encoder which produces parameters mean and covariance. These are essentially the parameters of a distribution which I'm going to call Q phi set given X. So this is normally distributed with mean, mu phi and sigma phi. Okay. So from this distribution, you produce a sample Z. Once you have this sort of a sample, you pass it to a decoder. This decoder models the distribution p theta x given set, right? So you get the parameters of p theta x given set, and now you sort of try to maximize the objective function as a function of theta and phi. So phi are the parameters of encoder, theta are the parameters of decoder, and in between there is a sampling step which is going on, right? So what is the objective function? The objective function consists of log of p theta x given z minus the KL divergence between q phi z given x and p of z. So p of z is some fixed prior onset. This could, for example, be standard normal distribution. This particular term acts more like a regularization term, and this particular term is the reconstruction error. Now, how do we sort of maximize this? In order to maximize this, so note that there is a sampling going on over here, right? So we can train through backpropagation, but the problematic step is the sampling step. So the question is that how to perform backprop through sampling. And the idea is that what we can do is that we can use this reparameterization trick. So this reparameterization trick expresses z as mu plus sigma to the power half times epsilon. Okay. So mu and sigma, right? They are the parameters coming outside the encoder, right? So these are produced by encoder. Mu phi is a function of x and sigma phi is a function of x. And this epsilon is a standard normal noise. Okay, so yeah, so any questions at this point? So can we give faculty the permission to unmute at least and like write in the chat box at least for the faculty?
They usually type questions in the chat box if they have
Okay,
access.
but chat they have access to like do the faculty members at least have the access to be able to write in the chat?
Anyone can write into the chat.
I see. Because when I joined this call initially, so I think later you had to give me some permissions for unmuting also and for chat also. Initially, it wasn't there by default.
Participants, can you type in the chat? I think some of the participants type in the chat. Good afternoon.
Yeah, yeah, yeah. I think those, okay. Yeah, I'm not sure if everyone
Participants,
can.
can you test? Are you able to type in the chat box or not? Yes.
Okay. Okay. Yeah,
They
someone
they are
is
they are saying that
asking.
please make your
Color.
dark color.
Yeah, yeah, yeah. Sure.
And if you
Yes.
have any question, please type here so speaker will take in between.
Hmm. Okay. Great, great, great. So people are able to write. Okay. So the thing is that, okay, so this is the reparameterization trick. Okay. Okay, great that you are able to write. So any questions so far, please do let me know. If there is anything you want me to explain again, do let me know as well. Right. So the formulation for variational autoencoders is actually as follows. So it's a latent variable model. So there is a, okay, so if you want to model the distribution over X, so first you use a latent variable Z. Okay. And typically we say that, okay, this Z is coming from a prior distribution, which is standard normal, but it's not hard and fast rule that it has to be standard normal only. You could have picked it from any fixed and known distribution as well. And then we have this variable X conditioned on Z. And the goal over here is to maximize the log likelihood of the probability of X, right? So basically maximize with respect to theta, okay, log of p theta x, right? So what is p theta x now? So essentially, since it's a latent variable model over the continuous latent variable z, so I'll have to express it as integral over z p theta x given z dz, right? Because p theta x given z is the probability of x comma z, the joint distribution, and if I integrate over z, then I'll get the margin. Now the problem is that how do we perform this integration, right? So the thing is that if z lies in high dimensions, then essentially this will suffer from the curves of dimensionality, which means that in order to compute this distribution, we'll need to bin z over exponential number of bins. So this suffers from curves of dimensionality. What would have been ideal is that if we could have taken those few z's which contribute the maximum to this particular term, right? So how can we do that? So basically the idea is that we need to sample those sets which are relevant for X in order to approximate that term. One way to do that could be that maybe if we could have sampled from the posterior distribution of Z given X. But then we face two problems. First one is that exact posterior may not be computationally feasible. Computation of exact posterior may be hard. That's the first challenge. Secondly, that even if we can, right? So how do we express log px? Okay, how do we express this as an unbiased estimator, as an unbiased? Okay, so how do we? Okay, so how do we obtain an unbiased estimate of log px using posterior? So these are the two challenges, and it turns out that if you just rewrite a few equations, everything falls magically into place. And what we are going to do is that we are going to use something called as elbow or evidence lower bound. So this color is also visible. This it's okay, it's purplish, or you want me to use
Yes,
black
it is
only?
visible.
Okay. The idea is that we use evidence lower bound or elbow. So first we have the following claim. That for any distribution QZ, so this QZ can also be a function of X, okay? So what we have is that the log probability of X can be expressed as expectation over Q log of Pxz over QZ plus the KL divergence between QZ and PZ given X. So does everyone know what is KL divergence? Okay, is there someone who does not know what is KL divergence?
Say yes or no. Are aware with this?
Okay, so if you know K, okay, so if you do not know KL divergence, you can raise your hand. Okay, one person. Okay, any other? Mhm.
There are
Yeah, so three people have, okay, six people have raised hands that they do not know KL divergence. So apart from these six, everyone knows what is KL divergence.
maybe you just discuss.
Seven. Okay, okay, okay. Yeah, no, but I want there to be some activity that will keep everyone engaged.
Many people are not.
Okay, okay, okay. Sure. Okay. Okay. So, okay. So who knows about it? If anyone. Okay. So yeah, you can put your hand down. So now someone who knows KL divergence, they can raise their hands. Yeah. So, okay. So now people who have raised their hands, they know about KL divergence, right? So, let's say, okay. So anyone who wants to answer, like, what is it? Like, who knows and wants to answer?
One person has typed in chat box.
Uh-huh. Yeah. So, okay. So, Dr. Abhay Singh, yeah, you want to tell us about KL divergence? Or Arju sir, Abhay sir, anyone who wants to unmute? Can we give them permission to unmute?
Participant, please unmute
Uh, So maybe one of
Abhay
them,
Singh
maybe,
Bhadoria and
let's
Arju.
say, yeah, so, okay. Yeah, so Arju sir, yeah, you can unmute yourself. You can tell us what is KL divergence.
Liza, can you unmute this and one of them, Arju Javla or Abhay Singh?
Yes, sir, I have given permission to him. He can unmute
Please
his mic
speak.
right now.
Abhay Singh or Arju Javla, are you there? Please speak. Abhay Singh is not unmuted. Abhay Singh Bhadoria.
Okay, no, no, we don't want to force them. So anyone who wants to speak, who wants to tell us about KL divergence?
Abhay Singh, please try now.
No,
Your
not
mic is unmuted.
necessarily. I don't want to pressurize anyone, but anyone who wants to tell what is scale divergence. Okay,
Abhay Singh, now you
so
can try.
y- yeah, they are saying that they are not. He's not unmuted. So okay, okay. So anyways, I'll continue then because he's unable to unmute. It seems they written in the chat. but let's continue. Okay, so essentially the idea is that KL divergence between two distributions Q and P in general is given by expectation over Q log of Q over P. Right? And there is a property that KL divergence is always non-negative. Okay, so I'll just put a box around this because it's a side note. Okay, and let's continue what we were trying to do. Okay, so we have written log P of x in terms of as a sum of two terms. There is a KL divergence term and the other is another expectation term. Okay, and this KL divergence term is of course non-negative. Okay, so since this is a non-negative term and summing that with expectation over q log of p xz over qz, that gives me log px. So what I can immediately claim is that expectation over q log of p xz over qz is less than equal to log px. So does everyone see why? So all the older participants can now put their hands down. Those who had raised their hand on the earlier question. Okay. Yeah. So anyone who does not see why this is true, this equation is true, you can raise your hand. So everyone sees why this is true, this particular inequality. Okay. Yeah. So essentially, the thing is that log of px is there is a non-negative. So this particular term is less than equal to log px. Okay, that is the first thing. Now the next question is that can I choose? Is there some distribution q under which these two terms will be equal? Expectation over q log px over qz and log px. Is there some distribution q under which these two terms are equal? Anyone wants to write in chat? Well, there is. The thing is that if KL divergence is 0, then these two terms must be equal, right? And when is KL divergence between two distributions 0? It occurs when the two distributions are the same. Right? So if Q and P, they are always equal, then essentially I'll have expectation over Q log of 1 and log of 1 is 0, right? So essentially, if if we choose if Q of Z equals P of Z given X, right, then log of Px equals expectation over Q log of Pxz over Qz. Then these two are equal. Okay. Uh, so essentially, in general, expectation over Q log Pxz over Qz is less than equal to log Px. But under some distribution Q, it becomes equal to log Px. So essentially, log Px is an upper bound on this expectation, but no, it's just not any arbitrary upper bound. It's an achievable upper bound, meaning that there is some distribution Q for which this becomes exact. Okay. So in other words, what we can say is that if I maximize over all distributions Q expectation over Q log Pxz over Qz, then I'm going to get log Px. Right? So this distribution which I'm choosing must be dependent on X. Okay. So does everyone see why? Right. So are people Busy in election results.
All
Okay.
participants are requested to actively participate in the presentation, please.
Yeah. 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 Because then, okay, I'll also feel convinced that what I'm saying is making sense to all. Okay. So I know everyone is a faculty member here. So, but if there is a question, do not feel hesitant. Okay, I'll always be happy to explain. So the thing is that if you now want to maximize with respect to theta log p theta x, then essentially what you can do is you can maximize with respect to theta, maximize with respect to the distribution q, expectation over q log p theta x comma z over q of z. Okay. Now the question is that how do we now maximize this q? How do we maximize over the distribution, uh, over the set of distributions q, right? So to maximize over q, we choose q from a parameterized family q phi z given x. Okay. Okay, so I'm writing it as a posterior, but this is not actually a posterior. It is just a distribution which is dependent on x. But the thing is that when it is maximized, it will be taking values which equals the posterior distribution pz given x. Okay, but I'm not hard coding it to be a posterior. I'm just saying that in the end it will be, but in general what we are trying to do is that we are just trying to choose a family of distributions which is dependent on x. So I can actually, I should have written it as q phi z parameterized by x. Okay, so now essentially we have two distributions. So first is likelihood, which is p theta x given z, and next we have posterior, which is q phi z given x. And now the elbow which I'm maximizing is nothing but expectation over q z given x log p theta x comma z over q of z given x. So what I do is that I write this numerator as p theta z or pz because z is not parameterized, p theta x given z over q z given x. Okay. Now this logarithm I break it into two terms. The first term is expectation of q phi z given x log p theta x given z minus KL divergence between q of z given x and p of z. So p of z I can choose to be a standard normal distribution, and then this first term is like the reconstruction term, which means that given z I want to reconstruct back x, and the second term is a regularization cost. So let's go back to our original formulation of VAEs. So earlier we were calling it an autoencoder. We were calling this as an encoder, this Q phi, and this P theta x given Z was a decoder. So essentially given an input X, I use this encoder, which is a parameterized network, which produces the parameters mu phi and sigma phi, which form the parameters of this distribution. I sample from this distribution, and then I use the decoder. I try to produce the distribution p theta x given z. I maximize the log probability of recovering back the original x, right? Then that is what I feed into log p theta x given z, and then I also have a regularization term which tries to compute the regularization between the KL divergence between q phi z given x and pz. Right. So this was what we essentially explained algorithmically, and now we have derived it as well. Right. So this is called as evidence lower bound or elbow. Okay. Let's take a break for 2 minutes, and before moving on to diffusion models, if you have any questions until here, please do ask, because the rest of the talk will be based on this. Okay, chalo, let's continue.
Any question? If you have any question, even it is a basic question, please don't hesitate to ask. You can type in the chat box if you are not type in the chat box. Any response? Can you type in the chat box? Are you there? Are you getting? Are you not getting? Or it is going above to your level? So please type anything that at least speaker can understand that participants getting or not.
Okay, let me continue. So now we move on to the main topic of today's talk, which is diffusion models. So before actually starting diffusion models, we'll just try to see what we can do. If we want to make this variational autoencoder more powerful. So this idea is called as hierarchical VAE or hierarchical variational autoencoders. Okay. So this is a so what is a hierarchical VAE? So it's a sequence of latent variables forming a Markov chain. To capture the following distribution. So what does it like? So basically, so there is a latent variable zt, and then conditioned on zt you have zt minus 1, conditioned on zt minus 1 you have zt minus 2, and so on until you have z1 and then followed by your x. Okay, so the zt, we assume that let's say it comes from some known prior, let me just call it standard normal distribution, but it can be anything in general. And then this x is essentially my data. So we have a sequence of latent variables. And now essentially we want to sample them one by one. Okay, so someone is asking, it's Abhay. So he's asking, what is the one-liner about diffusion model, right? And why are they useful? So essentially, I didn't actually describe it earlier. I should have started the talk with that. So essentially, diffusion models essentially enable you to generate samples from data. Typically, these are used for image generation models, right? One of the biggest applications is in image generation, but people have also tried using them for generating music, for audio, speech, text as well. But typically, vision has been their major application so far. Most of the existing image generation models, which you know about, like DALI, ImageGen, Midjourney, most of them are based on the ideas from diffusion models. Okay, what we are studying today is the mathematics behind the diffusion models. Okay. So let's say you have the sequence of these latent variables, and then one by one you sample the latent variables, and then you get to your data. So the joint distribution of all the latent variables and your data, right? So how does it look like? So you have data is x and then z1 up to zt. That can be expressed as probability of zt, which is coming from some fixed prior, and then probability of zt minus 1 given zt minus 2 given zt minus 1, so on until probability of z1 given z2, and then probability of x given z1. Right? So what I do is that I write it in a notation which is probability of zt times the product of t going from 1 to capital T, p theta of z small t minus 1 given z small t. So here, of course, this z naught, I'm just going to define it as x. Okay. Fine until now? So basically, this is just a Markov chain, right? So how do you write the distributions over a joint distribution of a Markov chain? This is how you will write. Now, what will be the corresponding posterior distribution, right? Because again, I want to use that same elbow lower bound. So I need a posterior distribution. So that will be of the form q phi z1 up to zt given x. Right? So how is it going to look like? So note that if the original set of random variables, they form a Markov chain. If I reverse the sort of order of variables, that will also be a Markov chain, meaning that there is also a Markov chain going from x to z1, z1, z2, z3, z4 up to zt. So if I have to condition this on x, the way I'll generate posterior is as follows. That firstly, there is going to be a term of q phi of z1 given x, then q phi of z2 given z1, and finally q phi of zt given zt minus 1. So what I'll do is that I'll denote x by z naught, and now I can just write it as this form, product of t from 1 to capital T, q phi of z small t given z small t minus 1, right, where z naught is defined as x. Okay, so note the following. Okay, when zt minus 1 up to x, they form a Markov chain, so does the reverse sequence, meaning that x, that is x, z1, z2 up to zt also forms a Markov chain. Okay, and now we can actually still use the same elbow lower bound. Why? Because essentially z1 up to zt together they form a sequence of latent variables. So I can use the same elbow lower bound on the sequence of latent variables. And what I get is that log probability of x is greater than equal to elbow, which is the expectation of q phi of z1 up to zt given x log p of x comma z1 up to t over q phi of z1 up to t given x. Okay, so this is what is hierarchical variational autoencoders. Now we come to variational diffusion models. So a variational diffusion model is essentially a hierarchical variational autoencoder with following additional constraints. Okay, what are they? Firstly, zt comes from standard normal distribution. Secondly, q of zt given zt minus 1 comes from normal distribution with mean proportional to zt minus 1, and variance covariance matrix as 1 minus alpha d times identity, which means that it's a multiple of identity, which means that all the non-diagonal terms are 0 and all the diagonal term, all the variances are equal. So notice one interesting thing. Here we are not parameterizing the posterior at all. So the posterior does not have any additional parameters, right? So it is not trainable. So firstly, it is not trainable. And second thing which you will observe is that dimension of zt must be same as dimension of zt minus 1. Why? Because zt is coming from a normal distribution whose mean is proportional to zt minus 1. So essentially all up to z capital T, if I go up to, then essentially all dimensions equal the dimension of x, which is the dimension of data. Okay. And since all these dimensions are equal, actually, just to remember that what I'll do is that I'll call all of these terms as x's. So I have xt minus 1, xt minus xt minus 1, then x naught is my data. And up to x1, all of these are latent variables. The question is that how to compute elbow for variational diffusion models. So that's what we are going to do now. So that elbow is expectation over Q. Yeah. Someone wants to speak. Mm, uh, Someone has a question. Uh,
So you continue. I think.
okay. Essentially, elbow is expectation over Q x1 to t given x naught log of p of x0 to t over Q of x1 to t given x naught. Okay. So we'll expand this. Before we do that, any questions? No questions. Okay, so let's expand this. So the way I'm going to write the joint distribution of x0 to t will be as follows, that there is xt which is the prior, then xt minus 1 given xt, and so on until p of x naught given x1. X naught given x1 meaning the data. Okay, let me also write this x1 given x2 also, dot x1 given x2, x naught given x1. And in the denominator, so if you remember when we wrote down the distribution of Q of z1 up to zt given x, what we did was that we started from x, so z1 given x, z2 given z1, zt given zt minus 1, and so on. So here also I could have done the same. For Q, I could have written x1 given x naught, x2 given x1, up to so on until xt given xt minus 1. But then that causes a problem because in the numerator, I have terms of the form xt minus 1 given xt, and denominator would have given me the terms of the form xt given xt minus 1. So it would be difficult to combine them, and there is a way to combine them, but that makes the computation complex. So what we do is that okay, so I am not going to explain why it becomes complex. For that, okay, you can watch my YouTube video, which I have for which I have given the link already. But what I would suggest is that what I'll do now is that I'll just directly write the correct way to expand it. The correct way to expand it is that I'm going to start from xt only. So since x naught is something I've already conditioned on, so I'm going to write it as xt given x naught. Then I have xt minus 1 given xt and x naught. Now when I come to xt minus 2, I'll have to condition it on xt minus 1, xt and x naught. But note that when I've already conditioned on xt minus 1 by Markovian property, I don't need to look at xt. Similarly, next, when I'm going to write xt minus 3, someone wants to ask. So what I'll have is xt minus 3, that will be conditional on xt minus 2, xt minus 1, xt and x naught, but just xt minus 2 will suffice. So basically I don't have to go to xt minus 1 and xt, and then x naught is obviously there. So and so on. Basically I was just giving examples that terms of this form will be there. But so on if I continue until where? Until q of x1 given x2 and x naught. Now, if I look at this pxt and qxt given x naught term, I try to combine them, and then I have xt minus 1 given xt and q of xt minus 1 given xt x naught. So I combine them, and then p up to so on until p of x1 given x2 and q of x1 given x2 and x naught, and then this term I leave separate, p of x naught given x1. So if I write it in this manner, I'm going to get terms of the form of expectation over q. So basically first I'll try to take this out, log of pxt over q of xt given x naught. Okay, and now I look at all these terms until p of x1 given x2 and q of x1 given x2 x naught. So basically in the numerator I have terms of the form of expectation over q. So it's expectation of q is there, but then the numerator consists of terms of the form of xt minus 1 given xt, and denominator consists of terms of the form of q of xt minus 1 given xt x naught. And where does t go up to, right? So initially I have small t equals capital T, right? Because it's conditioned on x capital T. In the end, it's small t equals 2. So the summation is from 2 up to capital T. And then finally, there is one term left over which I should not forget, and that is expectation over q of log of px naught given x1. Okay. So the expressions for this term and all these terms, it looks like KL divergences, which I'm going to write right now. But notice that the first term does not have any trainable parameters. Why? Because pxt is set to standard normal, and all the q terms, right, including q of xt given x naught, all of these, they do not have parameters. So this is called as prior matching term. But it does not have training parameters. So when I'm maximizing with respect to the parameters of theta, I can just ignore it because all the training parameters are in p theta, but pxt does not have any trainable parameters. So the trainable parameters are in these two terms. Okay. Now when I wrote q over here, what I meant was q of x1 up to xt given x naught. But here essentially only x1 is important in this term. So I'm just going to write q of x1 given x naught. And in this term, only xt and xt minus 1 are important given x naught. So question, so does this term look like KL divergence? So I'll rewrite it, okay, more clearly. This is term 1. This I'm anyways throwing away because it does not have trainable parameter. This is term 2 and this is term 3. So I'll rewrite term 2 carefully. So there is a sum overall small t, but each term in that looks like q of xt comma xt minus 1 given x naught log of p theta xt minus 1 given xt over q of xt minus 1 given xt x naught. Okay. Okay. So does it look like KL divergence? Or what is it that prevents me from writing it as KL divergence? Anyone? See, it looks like the negative KL divergence between Q and P, but Q is the conditional distribution of xt minus 1 given xt x naught, and here I have xt and xt minus 1 given x naught. So what I first write it as expectation of Q of xt given x naught under this is the expectation of xt minus 1. So there is a toward expectation xt minus 1 given xt x naught. Okay, and then I have log of p theta xt minus 1 given xt over q of xt minus 1 given xt x naught. Right? And now can you tell me whether it's KL divergence? Tell me. See, so there is expectation outside, but within that what I have is minus of KL divergence between Q of xt minus 1 given xt x naught and P of xt minus 1 given xt. Okay. And what else do I have? So I have this third term, which is expectation over Q of x1 given x naught. Actually, I can write it as x1 given x naught because I only need x1 and x naught given x1. But actually, this also I can multiply and divide by Q of x1 given x naught. Okay. And that gives me expectation of Q of x1 given x naught log of Q of x1 given x naught minus KL divergence between Q of x1 given x naught and P of x. Okay, this one I'll not write it as KL divergence specifically. This term I'll leave as it is for now. Okay. But the second term, like the terms, actually it's not one term, but these are capital T minus one terms. So these I've expressed them as KL divergences. Now the question is that how do I train such a model? So note that Q of xt minus 1 given xt x naught, right? This does not have any parameters. So I can actually compute this. How do I get this? Well, what I can do is that essentially I can use the Bayes theorem. Okay. So how do I do that? What I have is xt given xt minus 1. And I need to compute xt minus 1 given xt x naught. So if you remember, when we defined this variational diffusion models, we had defined xt given xt minus 1. So what I'll do is that I'll rewrite this as q of xt minus 1 comma xt given x naught over q of xt given x naught. This comes from the definition of conditional probability. And now I rewrite it as q of xt minus 1 given x naught times q of xt given xt minus 1 and x naught. But conditioned on xt minus 1, xt is independent of x naught by Markovian property. And then I have q of xt given x naught. Okay. Now you know this quantity. And these two quantities I can actually point you to the lecture notes by Calvin Lowe or my videos. But you can actually compute q of xt given x naught as, and it's not very hard either, as normal distribution with mean square root alpha t bar x naught and variance 1 minus alpha t bar identity. So here alpha t bar is nothing but product of I from 1 to t alpha I. So you can actually put this in. And what else do you need? Q of xt given xt minus 1. So if you have xt given x naught, so you can similarly you have the expression for xt minus 1 given x naught also. And what else do you need? Xt given xt minus 1. So this anyways was given as part of definition of of these variational diffusion models, right? So note that between these two, the thing is that you have alpha t bar x naught, and here we have alpha t xt minus 1, and there are square root signs also. But so the idea is that you have expressions for all these three, and you can substitute it in. And what you will derive is that q of xt minus 1 given xt x naught is normal distribution with mean mu q as a function of xt x naught and variance sigma q. Right. So it turns out that this mu q xt x naught is a linear combination of xt and x naught. So there is a long expression for this. I'll just write it. You will have to derive it yourself or maybe watch the videos and read the notes. But this is what you will get. But the important thing to look at is that it's a linear combination of xt and x naught. And the covariance matrix is something independent of xt and x naught. And in fact, it's a multiple of identity. So I'm going to just call it sigma q as a function of t. So essentially, this is how q of xt minus 1 given xt and x naught is going to look like. Now, when I had these KL divergence terms and I want to minimize the KL divergence, ideally I should choose P of xt minus 1 given xt to be something, which looks like the same as the expression of Q of xt minus 1 given xt x naught, because if these two are equal, then KL divergence is 0. So since I'm maximizing this term and this term is negative of KL divergence, so I'll need to minimize KL divergence, which means that I need to set these two distributions to be equal. Okay. Yeah, so someone is asking link to YouTube channel. I'll anyways post it here. I had actually posted at the beginning of this talk. I'll put it again here. Yeah, I'll put it over here. So please subscribe to this channel. Okay, so this link is there. Yeah, I've just put it in the chat. So just open it and you can just subscribe to this channel. So this is how the distribution Q looks like since I want to minimize the KL divergence. So what I'll do is that I can set P of xt minus 1 given xt to be of some similar form so that when they are equal, it will be 0. So set need to ensure P of xt minus 1 given xt is close to Q of xt minus 1 given xt x naught. Mm. So, okay. So P of xt minus 1 given xt has this form of normal distribution. So I'll choose P theta xt minus 1 given xt to be of normal distribution. And what should I choose the variance to be? Same as the variance for Qxt minus 1 given xt x naught. Okay. Now, what will be mu q? Okay, what should be mu theta? Okay, so mu theta has to be a network which should take as input xt and produce this quantity, right? This particular quantity. Then essentially I'll be able to minimize this. Now it can be shown that in this case, if we parameterize it in this manner, then minimizing KL divergence is equivalent to minimizing squared norm of mu theta xt as a function of xt and t, and mu q as a function of xt and x naught. So note that mu q can take as function both xt and x naught, right? Because q is a function of xt minus 1 given xt and x naught. Whereas p can only take as input xt, it can't take as input x naught. If it would have taken input x naught, I would have been able to set it to 0 because I know the expression for mu as a function of xt and x naught, which is this linear combination. So essentially, I need to minimize this sort of, the squared norm of this sort of difference. So what I'll do is that I'll reparameterize mu theta as a function of xt and t as square root of alpha t 1 minus alpha t bar xt plus square root of alpha t minus 1 bar 1 minus alpha t times this basically x naught hat. So this is a parameterized network as a function of xt and t parameterized by theta over 1 minus alpha t. And now if I resubstitute these in that expression for squared norm difference, what I'm going to get is essentially so if I just resubstitute it over here, if I substitute mu q and mu theta, so note that mu q and mu theta are the same expressions, except that mu theta has this x naught parameterized by theta and mu q has the actual x naught. So that KL divergence, minimizing that is equivalent to minimizing the squared norm difference between x naught hat as a function of xt parameterized by theta and basically the actual x naught. So there is a predicted estimated x naught and an actual x naught, and this is the estimated one is parameterized by theta. So there is a network which takes as input this xt and tries to recover back x naught, and this is the and then I take the squared norm difference between this and the actual x naught. Okay. So basically, the idea in minimizing those terms, minimizing the scale divergence term, is that given x naught, I sampled a noisy version of xt and then I try to recover back xt. But since xt given x naught, as I had discussed, is normal distribution with mean square root alpha t bar x naught and covariance 1 minus alpha t bar identity. So essentially minimizing, recovering x naught can be said as recovering a noise in this sample, right? So from this distribution, what we have is that xt is square root of alpha t bar x naught plus 1 minus alpha t bar, square root of 1 minus alpha t bar times a noisy sample. So essentially, what I can do is that x naught I can re-express it as xt minus 1 minus alpha t bar epsilon naught over square root of alpha t bar. So essentially, from this xt, if I can recover x naught, I can also recover epsilon naught. Okay. So basically, more formally, what I can do is that the network x naught hat as a function of xt t parameterized by theta, I can actually rewrite it as, I can parameterize this as the above, right? Which means xt minus 1 minus alpha t bar epsilon naught hat parameterized by theta, epsilon naught hat as a function of xt parameterized by theta over square root alpha t bar. And essentially, what I can show is that minimizing the squared norm difference between x naught and real x naught can be equivalent to minimizing the difference between the noise, the computed noise and the actual noise. So basically, what we are doing over here is we are learning the noise parameter given xt and t. And actually, learning noise can be recast as learning something called as scores. So score of a distribution is gradient over x log pxx. That is something we are not going to discuss today, but essentially, this led to the idea of stochastic differential equations, and even this classifier guidance is based upon this idea of score matching. We are not going to do those topics today, so please watch the YouTube playlist to get a more detailed idea, and I'll also uh, give you a link to some tutorial by Calvin Luo, which you can read. I'll just give you that link. Yeah. So that's it for today's lecture. And yeah, if you have questions to ask, there are 10 minutes left. So let me know whatever you want to learn now. Yeah, and yeah, so this YouTube channel, please do subscribe. You can open this link, you can subscribe now. There is some time before the next lecture starts. So until then, please open this YouTube link and subscribe this. Okay, by the way, today in Delhi, there are also these elections, and there is some counting of ballot scores which is going on today. So in fact, I have a video on this Bertrand's ballot theorem also. So it's unrelated to today's talk, but essentially the idea in Ballott's theorem is that, let's say you have two candidates for elections, and their total votes which are there are P and Q, but during the ballot counting process you're counting the votes one by one. So let us say P is greater than Q, which means that candidate A wins the elections. So what is the probability that, if you first uniformly shuffle all the votes and then count them one by one, so what is the probability that A maintains a lead throughout, right? Because right now you would be seeing that sometimes candidate A is winning, sometimes candidate B is winning, but what is the probability that candidate A maintains a lead throughout? So that is actually given by P minus Q over P plus Q, and this goes by the name of Bertrand's ballot theorem. This was initially proved by someone called Whitfield in 1878, and in 1887 Bertrand rediscovered it, but it's named after Bertrand. So I have a video on that on my YouTube channel, and so please do watch that video for a proof of why it's P minus Q over P plus Q. Okay, so thanks a lot. I have shared some YouTube links. Please subscribe to this channel and make your students also subscribe to it. if they want to learn about diffusion models and other topics in machine learning and also quantum computing, which I also teach. So thanks a lot. If you followed the lecture, it's really great. If not, then you can watch the YouTube channel. If you followed the lecture but you want to learn more in detail, again watch the playlist on the YouTube channel. Okay, thanks a lot.
Can take one questions if you have any
Sorry. Yeah, please to ask. Yeah, please to ask.
related to this talk. Please, you can ask or any application or any basic question.
Yeah, please to ask.
Don't know why today they are not asking any.
No problem, but you can watch these videos again on YouTube channel and please to send me questions on my email address. I'll type my email ID as well. Okay. So has everyone opened that YouTube link in the chat?
Response in yes or no.
Okay. Yeah, thank you. And please to subscribe to the channel also. Once you have opened that link, please to subscribe to the channel. So there is a good playlist on diffusion models, and so you'll be able to understand this topic in great depth after you have subscribed.
I hope you have any questions till now. As speaker
Yeah. So
suggested,
later,
you
if
can
you have questions after watching those videos, you can send me on this email ID also. If today you want to ask, please do.
see. Can conclude.
Okay. Yeah. Thanks all.
Thank you so much, sir. We are grateful to Mr. Dhiraj Madan for an inspiring and informative session. The knowledge shared today will have a lasting impact on our participant. Your in depth insight into the diffusion model in generative AI, along with the detailed discussion on the KL divergence, were truly remarkable. The way you explained these complex concepts, their applications, and their significance in AI research provided an immense value to all the attendees. Thank you once again. So, thank you for your time.
Yeah. Thanks for giving me this opportunity. Yeah. Okay. Bye. And please don't forget to subscribe. Okay, if you haven't already done. Okay.
Yes, sure, sir.
Yeah.
Thank you,
Bye.
Mr.
Bye all.
Dheeraj, for your nice talk and explanative talk. I
Thank you.
like that the way in which you.
Sure. Yeah. Thanks.
Thank you for
Thanks for.
accepting our invitation also.
Uh, sure. Thanks for giving me this wonderful opportunity. Okay. Bye.
Thank you, sir. Bye.
Thank you. Bye.
We have to wait for 5 minutes, starting the next session. Start at Hi, Mohit. Hear me?
Hey, hi. Yes, I can hear you.
No, can share the presentation so we can check.
Sure, give me a sec.
Meanwhile, Arshi can start one of the Mohit Jain.
Is my slide visible?
Yeah, it is visible.
Okay.
Pinky, are you there? You can introduce.
Yes, sir.
Yes,
Yes, sir.
please.
So, a very good afternoon to everyone. So, let's continue with the next session and welcomes our esteemed speaker, Mr. Mohit Jain, who will be presenting us on the topic Gen
He is
AI.
Dr. Mohit Jain.
Okay, sorry, sir. It's Dr. Mohit Jain who will be enlightening us today on the topic Gen AI work in healthcare. It is my pleasure to introduce Dr. Mohit Jain. He is a principal researcher at Microsoft Research Lab India, working on low cost diagnostic and expert in the loop chatbots. He received his PhD in computer science and engineering from the University of Washington and a master's in computer science from the University of Toronto. While pursuing his PhD, he also worked as a senior research engineer at IBM Research. His research interests are in healthcare, ubiquitous computing, human computer interaction, and global development. He is a recipient of World Found Fellowship at the University of Toronto and a winner of the DFS Tech Chatbot Challenge by the Gates Foundation, the Agnes Graham Bell Award, the Multi Point Education Award at the Microsoft Imagine Cup, and two Best Paper Awards and three Honorable Mention Awards. Now I invite Dr. Mohit Jain to take over the session and share their valuable insight with us. Over to you, sir.
Okay. Hi. Thank you for the introduction. Is my slide visible? Because I see a lot of people on the
Yes,
comment saying
Yes, sir.
yes,
there
sir,
are.
it's visible.
Okay, good. Perfect.
If some participants are not able to see the slide, they can rejoin their MS team, and so
Okay.
that maybe.
Participants, those who are facing the problem with the visibility of slide, you may try to rejoin or check your internet connection for the visibility.
And randomly, some participant can reply. Are they able to see the randomly 4 5 participants may reply over the chat box?
Yes, sir, it's visible to some of the participants. They are replying in the chat box, sir.
Yeah, it's visible. So please check your connection or re-log in into your MS team. Please
Yeah,
tell.
usually restarting teams usually helps. Yeah.
Yeah,
Yeah.
you can tell better.
Yeah. Yeah.
Okay, sir.
Okay.
You
You
can
may
switch
Okay.
off
proceed.
your team.
I'll start. Okay. Yeah. Yeah. Hi, everyone. I'll just start my talk. Few quick thing. Please feel free to interrupt me in between if you have a question. You can also raise your hand and ask me a question. You can also just like yeah, chime in between. Okay. I'll just. Okay. So yeah. So hi. Again, I am Mohit Jain. I am a principal researcher at Microsoft Research Lab in Bangalore. And today I will be talking about Doctor in the Loop chatbot, which I also known as Dilbot. And through the Dilbot framework, we aim to bring doctors and AI together to enhance patient care. Okay, so I'll illustrate this with three ongoing deployments: Cataract Bot, Oncology Bot, and Asha Bot. Okay, just to keep in mind, so I'll be talking about two of my project. One is this chatbot project, which is more generative AI and LLM based thing. I'll also be touching upon one of my other project, which is my slightly older project, which is on low cost diagnostics. So I'll do that depending upon how much time I have left. Okay. So as we all know, patients, especially those undergoing critical treatments like surgery or cancer therapy, need timely, trustworthy, and precise medical information. Okay, something that only a doctor can reliably provide. However, India faces a significant doctor to patient gap with only 7 doctors for every 10,000 people. The escalating pressure on the doctor to accommodate more and more patients has led to reduced time per patient, negatively impacting their communication as well as information sharing. Moreover, doctors get asked similar questions across patient. For example, anyone undergoing cataract surgery usually asks when they can start watching the TV again or when they can eat their favorite biryani after the surgery. Answering the same questions repeatedly is monotonous and time consuming for the doctors. With the emergence of large language models, LLMs, there is a widespread optimism about their potential to make healthcare more accessible. However, LLMs are prone to hallucinate, they make errors, and also hence they are not suitable for direct use in critical domains or domains with high stake setting like healthcare. Okay. Even OpenAI's usage policy clearly states that GPT should not be used to provide tailored health, legal, or financial advice without review by a qualified professional. This raises an important question. Can we leverage the expertise of qualified medical professionals to improve AI systems? In return, can AI empower doctors to expand their reach and provide care to more and more patients? To answer these questions, we propose Doctor in the Loop chatbot, which are LLM powered WhatsApp bot to provide patient support while keeping doctors in control. Before building these bots, we interviewed a bunch of doctors, patient coordinators, nurses, and patients along with their attendants to identify key design requirements. And the most important, as expected, was accuracy. In our approach, an AI answer gets verified by a human expert, achieving 100% accuracy. Second, to accommodate end users with varying level of literacy and technological proficiency, we made the bot to work entirely on the ubiquitous WhatsApp platform and made it multilingual. So that right now it supports Hindi, English, Kannada, Tamil, Telugu, Urdu, and a bunch of languages. And also it is multimodal, so that it basically it accepts both text input as well as speech, basically voice message sentence input as well. Okay. Finally, since doctors are extremely busy, we need to ensure minimal additional workload for them. Hence, instead of asking them to edit every LM generated answer, they are only required to provide broad feedback on those answers. I'll give you more details about all of these in the next few slides. Okay. So let me walk through how exactly the system works. Okay. Whenever a patient, so let's say in this case, the patient is undergoing either a cancer treatment of their head and neck cancer or maybe an eye surgery. So they're asked this question. Let's say the patient asked this question: when can I wash my hair after the surgery? Okay. And as I told you, the bot support multiple languages. So they could have asked this language by sending a voice message recorded in Hindi. And okay, so right now, based on this question, we have curated a knowledge base with the help of the doctors and nurse and the quality control staff at the hospital. And using that knowledge base, we run something called as retrieval augmented generation, RAG pipeline over it to get this answer, which says you can wash your hair 3 days after the surgery. Not only that, we also use RAT to identify three related questions so that the patient can continue the conversation. Finally, we also do a classification wherein we identify whether a patient question is actually a medical question. In that case, it should go to a doctor. And if it's a logistical question, it should go to a nurse or a patient coordinator. And if it's a acknowledgement or just a thank you kind of a response, it should be answered directly by the bot without going to an expert verification. Okay. Let's say in this case, it is a medical question. So it goes to a doctor. And what we send to a doctor is the question that the patient asked, along with the answer that the LLM has generated, along with the patient demography, the name of the patient ID, the age, the date of the surgery, along with the simple question, was the bot's answer correct and complete? So only on two parameter or on two metric, the doctor is asked to verify that answer. Now the doctor has three options: yes, no, and send to patient coordinator. So if the doctor clicks yes, the patient receives the green tick mark here instead of the question mark. And we also send a message that this answer has been verified by your doctor. If the doctor says no, we'll walk you through that use case. And if our system makes an error wherein a logistical question goes to a doctor, then the doctor can just forward that question to a patient coordinator. Let's say the doctor says no to this question. In that case, we inform the patient that the previously provided answer is invalid. We cross mark that question and we ask the doctor to provide a correction for this answer. Now, the interesting part is that the doctor is not required to manually edit that answer. The doctor is just required to provide a broad feedback on that answer. In this case, the doctor says something like, better to avoid for 2 weeks. And you can see that the doctor is writing in the shorthand form, which is not grammatically correct. But we take this input, the golden input provided by an expert, and we modify the answer that is given to the patient. The patient receives, better to avoid washing your hair for 2 weeks after the surgery, along with the same thing that I told before, like a green tick mark and saying this answer has been verified by a doctor. Okay. Now we have this gold information from a doctor. So we add that to the knowledge base so that next time a similar question gets asked, the patient receives 2 weeks as an answer and not 3 days. Okay. As the system has been deployed at a few hospitals across India, we added a few bells and whistles, wherein actually, if the doctor is not available to answer that question, we escalate it to a senior doctor. And if both of them are not available, we actually send them reminder messages. So our system makes sure that the answer gets verified by a doctor within a fixed period of time. Any questions so far? Yeah, I'll go ahead. The system has been deployed for cataract surgery at the Sankara Eye Hospital in three of their branches in Bangalore, Hyderabad, and Jaipur. And over the last almost close to a year now, 1,200 plus patients have used the system. They've asked more than 5,500 questions to it. There are 18 experts in the system right now, 12 doctors plus 6 patient coordinators. And the current figure is that for more than 90% of the questions, the doctor or the patient coordinator just have to click yes, that the answer is correct and complete. Okay. Not only that, we have open sourced the base framework. So, and we call that BO, which is Build Your Own Expert Bot Framework. And we have open sourced it on the GitHub Microsoft page and on MIT license. So anybody can now build an expert in the loop chat bot in just 10 minutes of the time. These are the core components of that system. So yeah, please go through the code if you feel like you want to learn more. Okay. Now we had this framework, so we used it for a bunch of other use cases. One was this OncoBot, which is a chatbot that we built for Kasturba Hospital in Manipal. And it helps cancer patients who are undergoing treatment at the hospital to get answers to their questions. The main difference between this bot and cataract bot is that in this bot, when a patient asks a question, we always give the default response saying that let me check with your doctor and get back to you with a verified answer. We never give them an unverified answer upfront. And only when the doctor has gone through the process, have corrected an answer or have just said yes to an answer, then only the response comes to the patient saying that this is the verified answer. Okay. We also built a system called as ASHA which is for community health workers. Some of you may be aware that there is a program run by the government of India. It's called as ASHA program, wherein there are women, slightly educated women in rural India who are being given the job of ASHA worker, which are community health workers, and they go from house to house to help women who are pregnant or women who have very young kids. So basically, like in the first 5 years of a kid to help with the vaccination or consulting a doctor or any kind of question that they have. So it's basically maternal care and child care. Okay. So deployed the system with our NGO partner Khushi Baby in two districts in the state of Rajasthan, Salumbar and Udaipur district. And right now, 2,600 plus ASHA workers have been using this system, and they've asked more than 12,000 questions in the last 6 months. Okay. Because in this system, we don't have a doctor as a medical professional who can verify the answer. We rely on a different kind of expert who are known as ANMs, auxiliary nurse midwives. So these are the expert or the supervisor of ASHA worker. Okay, so these are the expert in this system. So still we are using the same Dilbot framework, but instead of the doctor, now we have the ANM. Okay. Now in this system, how this system works is slightly different from the previous system. So I'll again go over it. Okay. So our chatbot, Asha bot, is strictly grounded in the knowledge base and always respond with an I don't know if a relevant answer is not present in the knowledge base. Okay. In such cases, we, as I told you, we cannot rely on a single ANM as they are not medically trained like a medical doctor. So our system forwards the question to a randomly selected group of ANMs. Okay. And it keeps on adding more and more ANMs until unless we receive 5 responses. After we receive those responses, the system checks the relevance of these answers. Okay. For example, if somebody has written good morning, in that case, we'll just remove those answers. Okay. Next, it checks for any kind of conflict in the answer. Let's say in this case, the one of the ANM said that like the question was, what are the side effects of Antra? One of the ANM said that, like, nothing, don't worry. While the other three ANM said that there are certain side effects, like the woman can bleed, there could be irregular period, and there could be weight gain. So now we do some kind of a majority voting. So in this case, the majority of them responded with some side effect. So that's the clear winner. And then we finally combine or aggregate these answers so that the relevant and similar pieces are stitched together to form the final answer. For example, we start with saying there are no potential side effects, but there are these other side effects, which are weight gain, stomach pain, bleeding, and irregular period. Okay. And then this answer, again, in similar to the cat bot scenario, gets added to the knowledge base so that somebody else, the next time somebody asks a question about the Antra, which is a contraceptive vaccine, we get the right answer. Okay. Now I'll talk to you about a few key challenges that we came faced while building the system and a few findings of our deployment of these systems. Okay. So first and foremost, because the system was deployed in multiple languages and also both as speech and text as input, so there were a lot of time that these system, the language technology system, made error. For example, in one case, we saw in the transcript that there was a question about slow mother-in-law. And we were very puzzled, like, what could this be? Why would an ASHA worker ask something about their mother-in-law? Okay. Uh, any guesses from the audience? What could have been the mistake here? Okay, I'll just go ahead. So basically, as we all know, because this was a question in Hindi, and we know that SAS and SAS are very close to each other, just with a small dot, which makes a difference. So SAS stands for the mother-in-law, while SAS means breathing. So the ASHA worker was actually about asking about the slow breathing pattern of a kid and not about their mother-in-law. But because of this transcription error, we were not able to correctly answer the question. Similarly, in other case, the same question, what are the side effects of Antaratika? It actually converted that into side effect of Antarctica. Okay, and then again, our bot failed to answer and gave I don't know response. So what we did in this system was that we actually started using the Azure OpenAI model for even for translation, because in the current speech to text model, we don't give any kind of context. But using OpenAI GPT-4, we can give a context saying that, oh, this question is being asked by Asha worker. Can you actually help it now translate from English to Hindi or from Hindi to English? Okay. Not only that, so that solved some of these errors, but there are certain things which could have been used by the ASHA worker. For example, somebody is asking about what are the roles and duties of ASHA, then ASHA gets converted into HOPE and not health worker. So we also added a lookup table to actually uh, fix some of these word translation. While deploying the system, we also identified that most of the ASHA worker understand or talks in English and not in pure Shuddh Hindi. Okay, so we started using OpenAI model for even for translation, for converting a English answer into a English answer. Finally, for the RAG pipeline, we found that if we pass on both the Hindi source question along with the English translated question asked by the ASHA worker, it actually helps in improving the language and it helps in improving the answer generation. I can see a few questions which is in the chat message, so I'll just quickly answer them. I think Ankur asked that the chatbot working on the AI or not. We are using GPT models to make the chatbot one. Also, there's a lot of language technology that is being used. So there is some AI, definitely. Um, Arshi asked in how many languages the chatbot is working. So right now we are supporting, I think, around 7 languages, which is English, Hindi, Kannada, Tamil, Telugu, Urdu. Yeah, or one or few more. Okay, moving on. The second challenge that we faced, and this was a very critical one, was that as I talked about the head bath example, the existing knowledge base states that it should be you can wash your hair after 3 days, while the new information provided by the doctor was that you need to wait for 2 weeks. So now, how should we update the knowledge base so that the next time somebody asks a question, we get a 2 weeks as an answer and not 3 days? So this because the new information can be contradictory to the previous information. So we tried a few solutions here. We asked an LLM to modify the relevant data chunks inside the knowledge base with based on the expert feedback. And however, that was a bad idea because LLM also like modified regions that should not have been modified. Secondly, we actually tried an approach where we added all of this expert feedback into a separate file along with the timestamp information and asked it that anytime that you have a question, or in any time that data chunk gets extracted from the knowledge base, give it a higher priority based on the timestamp that has been added to it. Finally, the third solution which works the best is actually we added the relevant data chunks or so relevant the expert feedback into the relevant data chunk along with the timestamp and prompting the LM that give higher priority to a newer timestamp value. Okay, so this one is in the current system which actually works the best. Uh, Now, in our current cataract bot system, the doctor needs to verify every LM generated answer, which not only increases their workload, but what we found was that after a while, the same question keeps on coming and the task become again repetitive and monotonous to the doctor. To reduce that, now we worked on a solution to deliver pre-verified answer, wherein for certain question, as the expert has already provided or marked the answer as correct a few times, so these are pre-verified answer, and now we can directly send those answer to the patient saying that this has been verified before. Does this answer your question? If they say yes to it, we are good. If they say no, then we follow the whole procedure. Okay. Here is a short video that I will play, wherein a doctor at the Sankarai Hospital uh, talked about like how exactly the bot is helping her. Is the audio of the video audible to you guys?
Yes.
Okay, perfect. Not only the system was easy to use for the expert, we also found the expert workload to reduce over time.
Excuse me, sir.
Sure, go ahead.
Sir, some of the participants are requesting to slow down, like you're going very fast, so they couldn't understand the things very well. So
I
can you
see.
please slow down this your speed?
Sure. Okay. Is there any specific thing that you want me to cover again? I can do that.
No, no, it's okay, sir. But now, please.
I see. Sure. Okay. So not only the system was easy to use for the expert, but also what we found was that the expert workload, actually the number of times they have to say no to an answer and actually provide a very edit or what I call it as a feedback to an answer, that reduced over time. So this is a plot showing that the total number of accurate and complete answer increased by around 20% in the first 6 months of deployment. And the number of times the I don't know answer from the bot actually reduced by around 8% because more and more answers were getting added to the knowledge base. So the knowledge base kept on expanding and hence I don't know reduced and the number of accurate and complete answers increased. So this resulted in the doctor manually editing only around 15% of the answer, which was very low compared to the 100% of the answer to begin with. However, it is still the 15% exists because there are questions like a patient asks, when can I do anulom vilom after the surgery, which was not present in the knowledge base, and the doctor has to provide an answer. Similarly, this is the common question where patient asks, what time is my surgery? Because our system is not integrated with the electronic health record of the hospital, it is impossible for us to actually identify which patient surgery is at what time. Okay, so then again, the patient coordinator needs to chime in and give a response. Uh, I'll just skip that. Now, so we also conducted a qualitative study wherein we interviewed patient, attendants, doctors, as well as patient coordinator to understand how they use CatrackBot. Similarly, we also interviewed ASHA worker and A&M to understand how they use ASHA bot. So here are a few key findings from those interviews. The first is that we found the bot to be accessible to even people who are low literate and people who have minimal technological proficiency. For example, a patient told us that without even asking me for help, my father, who is very low literate and who doesn't understand English that well, was able to use the bot as it supports Tamil, and I felt it was very useful. On the same note, a doctor told us that less educated or people who speak only their local language and not English are the ones who for whom this bot can do wonders. The people, on the other hand, people who are highly educated or who can talk in English, they are not hesitant in asking the doctors any kind of question. So they would anyways ask them the question and don't depend a lot on the bot. Going to the second finding, I think the very interesting thing came across was that the bot was non-judgmental in nature, which was very critical in these settings. For example, an ASHA worker told us that once there was a crowd at the maternity center, and it was very, very chaotic. And the ASHA mistakenly gave the vaccine, which was intended for a 6-month-old baby, to a 3-month-old baby. Okay. And she was very worried about it because she cannot ask that or admit that she has made a mistake and ask an A&M about it. A&Ms are ASHA supervisors, so she can't do that. So hence he asked the bot, and the bot replied saying that it's completely fine. The vaccine could be given to anyone between the age group of 2 months to 6 months, and she has not done anything erroneous. And then so that actually helped the ASHA. On the flip side, even patient in the cataract bot scenario also told us the same. A patient told us that his mother, who has cholesterol issues and is going to undergo a heart surgery, um, if about her, if they ask this question, what kind of food that she would eat, the doctor might make face and judge her. However, the bot is non-judgmental, so they were more comfortable in asking these questions to the bot rather than the doctor. Finally, the most critical component of all of this is trust. Okay, as the cataract bot patient told us, the trust only came when I saw the green tick mark. Okay, before that, I was also in the question mark zone. So this was also, I think, in line with what we have in the UI of the chat bot. And in that case, sorry, in that case, anytime a question is answered which has not been verified, the answer comes with a question mark, and once the doctor verifies it, a green color tick marks comes on it. Similarly, the patient said here only when the answer was being verified and they know that somebody was checking it, confirming the message, that it actually then became trustworthy. Okay. So this, just to conclude, this doctor in the loop framework has been evaluated at scale through Cataract bot, Oncology bot, and Asha bot. And right now we are in discussion to actually scale it further to Apollo Hospital, Narayana Hospital, or other groups of hospital. The critical thing to understand here is that the chatbot, these LLMs, not only make the bot accessible to these new group of people which are low literate and who are not technologically proficient, but it also reduces the power difference between an expert user or an expert in the field versus a end user in the field. So at a society level, it bridges the gap between these two group of people. In our case, the patient receives verified, reliable information, while it helps minimize the workload of the doctors. So it's a true win-win kind of a solution. The system is not limited only to healthcare. The framework can be adopted to other fields such as law, agriculture, finance, wherever there is an expert input is required. Moreover, the system is again not an India-centric system. It can be easily extended beyond India, offering a scalable global solution. Thank you. Any questions so far? Okay, let me do another, just continue on the talk. Okay. So now I'll be talking about this low cost diagnostics. So I mainly work in these two areas. I work a lot on LM based chatbot and I work on low cost smartphone based diagnostic solution. Okay. So I'll talk to you about this. This is again the work that I've done at Microsoft Research Lab with my partner Nipun Quatra. Okay. So let me begin here. Okay. Again, feel free to interrupt me and ask question or drop it in the message box. Okay. So as we all know,
Take the
health.
questions.
Sorry, come again. Word Anurag.
Participant, have any question, please raise hand or type in the chat box.
Yes. Yeah. Okay, let me start here. Huh?
There is a
So
question
as
in chat box.
okay, there's a new question. In what ways can chatbots assist in preliminary diagnosis and symptom checking? So the chatbot is not meant for that. Okay, that's a very risky use case of chatbot as per us. So it won't be helping anything with the diagnosis and symptom checking. It will only help you about your query that is before the surgery, during the surgery, or after the surgery. Okay, so all the symptom checking and diagnosis is being done by the doctor, and only once the surgery is confirmed, then only give access to the cataract bot to the patient. Okay.
But after the surgery, it may also be something patient will do against the
Come again. I wasn't able to understand the question. What's your
after the surgery.
yes?
Chatbot anything wrong, and again it could be.
Anurag, your voice is really low, so and also it's choppy. So I'm not able to understand the question.
Now am I audible?
Ah, much better, much better. Yes.
So I am asking the things. Suppose after surgery, some patient ask, is he want to put a oil over the stitches, and mistakenly chat box can answer wrong at that time, so that that the stitches will become bad in shape. So risk is also there after the surgery also, as you talked
Uh,
about the risk factor.
yes, yes, yes. So again, like I think depending upon which kind of model we are using, so there are two approaches. One is that on like even an unverified answer goes to a patient that we did for the cataract scenario, and or only a verified answer goes to the patient that we are doing with the oncology scenario. So if it's a very high stake thing like cancer, and so it's again up to completely up to the doctor based on the framework. We can just switch or like there's a boolean variable whether there should be a asynchronous answer, sorry, a real time answer given to the patient, or they should only be given asynchronous answer. Okay, this is basically only the verified answer. So, so yes, in case of cataract, the hospital asked us to do it wherein even the unverified answer goes, because their point was that if we don't give them an answer right away, then they will anyways just go and Google or ask somebody else, and might be even worse. They might get even worse information there. In this case, at least there is grounded information. Almost, so we saw very minimal of hallucination. Most of the answer, or I would say like almost like 100% of the answer in our case were actually generated from the knowledge base, and the knowledge base was curated by the doctors. Okay, so in this case, that is somebody asks a question, can I put oil over my surgery? It will just say, I don't know. And then the doctor
Okay,
has to respond yes or no in this
there
case.
may be
Okay.
such answers also. Okay.
I don't know is a very common. I told you na, that the number of I don't know answer reduced by 8% over time. So whenever our system is not able to find an answer, it just respond with a I don't know. That's it.
Okay. Okay.
Yeah. Like let's move on. No? Now I'll be talking about this low-cost diagnostics work, and let me provide a key motivation for this. So as we all know, healthcare is not accessible to a huge population across the globe, and there are a variety of reasons for it, yeah, including like skewed doctor to patient ratio. As I told you, there are only 7 doctors for every 10,000 people in India. Not only that, like even the healthcare workers are usually unskilled, and there is a lot of wait time and commute time just to see a doctor. Okay. And in rural India, that also result in loss of income because these are daily wage earners who go and meet a doctor for a day and then they are not able to earn that day. So all in all, this makes access to healthcare a very hard problem. Okay. So our aim in this work was to democratize, or like is to democratize healthcare. And by democratization, I mean that to develop low-cost smartphone-based diagnostic solution with AI assistant embedded in them to enable anyone, basically a community health worker, a teacher, a primary clinician, or even a Swiggy or Amazon delivery personnel to perform preliminary screening of certain diseases with minimal amount of training. Okay. And with that vision in mind, over the past almost like 5 years now, we have been working towards developing a variety of diagnostic tools from keratoconus diagnosis to blood pressure estimation, all using smartphone. So these work has been done in close collaboration with hospitals like Sankrai Hospital and even NGOs like Welthunger Hilfe. So let me quickly run you through each of these projects before I'll dive deep into the keratoconus diagnosis system because that is the most advanced stage. Okay. So the first one, keratoconus diagnosis, I'll talk to you in detail about that. While the rest five of them, I'll just give you like a one slide quick glimpse of it. Hmm, what happened? Okay, let me do this. Ah, okay. So this is a very interesting one that we solved. So this is called as dry eye detection. Okay, a few of you might be aware of it, that there is a disease called as dry eye, wherein your eyes get dry just because either it is not producing enough tear or the tear film that is formed is not thick enough so that most of the tear that it produces actually vaporize. Okay, and that result in the dryness of the eye. So just to keep your eye uh, wet, you have to keep on putting eye drops at least 10 to 12 times a day. Okay, this is very expensive disease to have. So what we did in this case, we actually used something called as the principle of thin film interference. And this principle is very simple. All of you would be aware of it. Whenever actually you see when oil is spilled over a surface of water, you see a rainbow of colors. Okay, and this you look something like this. Okay. Similarly, a healthy tear has a lipid layer, like a layer of oil over it, over the watery layer. Okay, due to which anytime you blink your eye, you can see this rainbow of color flowing over it. So if you have a thick lipid layer, you have a lot of oil over your eye, then you can actually see this kind of film over it, and that means it is a healthy eye. However, if your lipid layer is weak, okay, or your aqueous layer doesn't have enough water, then you will see this kind of a grayish color. And this is a symptom for dry eye, while this is a normal eye. So we use an interesting two phone setup where one phone was used to project this kind of a pattern on the eye, and the other phone was used to actually record the eye, okay, like a video of the eye. And then we use the this kind of setup to do to capture such a video. And then we had a video processing pipeline to estimate the thickness of this lipid layer, which is a quantitative measurement of the dryness of the eye. Okay. Uh, Moving on. Okay, as I told you, I'll just give you a quick glimpse. So I am wearing a glass. A lot of you must also be wearing glasses here. And we all know what is the refractive error of the eye. And you get like three of those value, like the spherical error, cylindrical error, and the axis at which the cylindrical error lies. Okay. So there is a device called as retinoscopy. And when they move the device from the left to right, okay, you can see the retinal reflex, a reflection from the retina comes in, which looks like this. Okay. And there are a few factors like how thick is this reflection, in what direction this reflection is going. So if the device retinoscope is moving from left to right, is the reflection going from right to left, or it's also going from left to right? What is the thickness of it, and how fast it is moving? So based on all of these parameters, there is a way for a doctor to keep on adding lenses to make sure when they are actually moving the retinoscope left to right, the reflex covers the whole eye and it is not moving at all. And at that point, you have a normal or a healthy eye. So again, in this case, we actually connected a smartphone with this retinoscope and collected videos of the eye of these movement, and then we use that on a video processing pipeline to automatically estimate the refractive error. Okay. Uh, Yes, as someone said in the chat, blinking rate will also help. Definitely for dry eye disease, the number of blinks per minute is also a factor to identify like how healthy your eye is. And if you can blink more, it actually reduces your dryness in the eye. Yep. But that's not a medical method of diagnosing dryness in the eye. The medical method actually relies on a similar principle. So there is a device called as LipiView by Johnson and Johnson, which uses the same principle of thin film interference to diagnose dryness in the eye. So our device, a smartphone-based device, was based on a similar principle. Okay. Uh, Finally, I think a lot of you must have trained a lot of deep learning model. So we also proposed a bunch of deep learning solutions for a variety of health problems. We trained an end-to-end DL network. We call it RespireNet to classify crackle and wheeze sound in the lung. So there is a big data set wherein they've recorded lung sound of babies, and we actually made this RespireNet framework on basically DL network, and we open source it, and we obtain state-of-the-art result. Okay, we also proposed a CNN-based architecture to estimate height of children under the age of 5 years for from depth images collected using a smartphone. Okay, so this is used for tracking the malnutrition or diagnosing if a child is malnourished or not. Okay. Mainly, there is a thing called as stunting, where there is abnormal growth. So if you know the age of the baby and you know their height, you can diagnose stunting. So this was for that purpose. And we also worked on a DL system to estimate blood pressure by just putting your finger to cover the back camera of a smartphone, along with the LED light being on. Okay, so we record something called the PPG signal here, and from that PPG, can we estimate blood pressure? So we worked on that as well. Okay. Now let me do a deep dive on our keratoconus work. Okay, so Smart Casey is a smartphone-based corneal topographer for diagnosing keratoconus. So there are two interesting or two novel terms here: corneal topographer and keratoconus. I'll talk about both of them. Just a preface: this work was done in close collaboration with doctors at the Sankara Eye Hospital in Bangalore. Sankara is a leading eye hospital chain in India with around 14 branches across India, and they perform more than 2 lakh surgeries every year. So that's a fairly big hospital, and we have a lot of interesting collaboration with them. Okay, so let's move on. Okay, um, so let me explain what is keratoconus. So a typical human cornea is shaped like a dome. You all know, like your cornea is shaped like a dome. However, a person who is suffering from keratoconus, they have a irregular shape of the cornea where it is bulging outward into a conical shape. Okay, so you can say like there's a normal cornea, there's a keratoconus cornea. Okay, it is outward and becomes more of a conical in shape. And the worst part is that keratoconus affects teenagers in the age group of 10 to 25 years. And it is the leading cause of blindness in that age group. Okay, particularly Indians are at a significantly high risk of keratoconus, as you can see the numbers here. Globally, it only impacts 0.05% of the population. In India, it impacts 2.3% of the population. So every around like 2 to 3 kid out of every 100 kid will have keratoconus. Okay, and there is nothing. It's not because of the bad healthcare system of India. It's mainly because of genetics and the weather of India. So genetically, Indians are born with a thinner cornea to begin with, and hence it is more likely to experience keratoconus. Second is that the hot, humid weather of India causes eye irritation, so which leads to frequent rubbing of the eye, and that can also result in distortion of the cornea. However, if this disease is detected early, it can be easily fixed with a prescription glass. However, as it progresses, surgery is the only option. So globally, 27% of corneal transplants are performed just to treat keratoconus. So early diagnosis is the key here. And the key idea behind diagnosing keratoconus is to understand the shape, basically the curvature of the cornea. Okay, and it uses a very simple system. We use something, so what like traditionally has been used is something called as a Placido disc, which is just a disc consisting of series of concentric black and white rings. And there is a hole at the center via which the doctor or the healthcare worker can actually see through it. Okay, to see the reflection of these rings on the patient's eye. Here, if and these reflection on the patient eye is called as Myers. Okay, so if these projection of the Myers are circular and spaced evenly, it means it is a normal eye, because then only it's because it's like a dome, and if it is all it's like a perfect dome, then the reflection will be perfect, and it will be circular. There won't be any spacing will also be even. However, a distorted cornea will result in a distorted pattern of Myers. Okay, so it will be either distorted in some way, and those such paper-based placidos are really cheap, and really, I would say, suitable. It requires a very expert doctor to use it, because it is very hard to use. Not only that, you don't have a digital record after this. So the same patient usually, because the critical nerve disease also progresses over time, so every 6 months they have to check like how bad the disease is. And to check for progression, digital record is very important. So they can't have that in such a system. So thus the clinical gold standard for diagnosing keratoconus is corneal topographers. And these are based on the same Placido principle that I talked to you about here. However, now this is just converted into a more fancy device. Okay, they have the same Placido, however, it is a 3D structure now, and they have a bunch of LED lights at the back side of it, so that the projection of these Placido, or basically the formation of mire on the eye, is more clear and more visible. Okay, and these devices, although they preserve digital record, obviously, and it does not even require a doctor to operate these devices, the worst part is that they're really expensive and they are huge. They're like this big, they take the space of a table, and they cost more than $20,000 for a single device. Okay. And at the end of it, they actually, the kind of image they capture looks like this. And here there are two of these images, and you can see that the left one is slightly unevenly spaced compared to the right one, but that also requires you to have some experience using this. So what it does is that, uh, instead of, along with giving these kind of Mire images, they also give something called as the curvature heat map. Okay, this basically gives out a 3D shape of the cornea in the form of a heat map. Okay, and if all of these rings are concentric with equal spacing, it is mostly a greenish or yellowish in shape. But if there are any bulging, it becomes appears more reddish in shape. Okay. So, so these kind of heat map also helps you in localizing where the keratoconus is impacting the eye the most. Now, the goal in our work was to develop a low-cost portable corneal topographer which captures high-quality Mire images and outputs curvature heat map. So there are three parts to the problem. Okay, so and hence our smart KCA system comprised of three key components. First, there is a Placido disk that we designed and 3D printed for projecting the Myers on the eye. Second, there is an Android application to capture the Meyer image on the eye. And the third, there is an image processing pipeline to convert those Meyer images into these curvature heat map. Okay, so let us go over these components one by one. Oh, these are the three components. Yeah. So we 3D printed a bunch of these Placido disk in different shapes, size, and different kind of design. Okay, and after a bunch of trial and error, we finalized this particular design, which you can see here. So it is like there is a cylinder on the outside, there is a conical shape in the inside, there is a gap, as you can see, between the shape. Okay, and then this is how you have to put it over the patient eye, like the eye goes here, if you can see my cursor. And then we have in the smartphone, it automatically captures a few images of the eye once it sees the eye in the video feed. Okay. It also have like these ring of like 12 LED lights so that the eye gets captured very properly. Okay. I think interestingly, the spacing in the Placido disk was very hard for us to figure out. Okay, because as you know that like the ring that is closest to the eye versus the ring which is farthest to the eye still needs to be of the same size on the reflection. And hence we did some kind of math to actually figure out how exactly to build this. Okay. And because of that, you can see that the thickness of the ring actually reducing as we move away from the camera. Oh, here is a nice video that I have for you, how it actually looks. So you can see there is a smartphone and there is a set of LED lights here. We are actually powering the LED lights from the smartphone to reduce the amount of hardware or electric wear that we have to put here. There is the Placido 3D print attachment on the left hand side. And you can also see there is a cone here sitting here. This is actually the a butter paper that we have folded, which acts as a diffuser. As the LED light will directly fall on the eye and it will be really hard for anyone to see anything. It will just blind the user. So hence we use this butter paper or a filter paper to filter the light, okay, to diffuse the light. You can see how it looks. So now it's like these are the light, and and I just and I put this butter paper over it to cover it, and then I will just this has a rotate and clock mechanism. So you have to just like put these three legs into these three holes, and we just have to like, yeah, twist it, and now it is locked. Okay, if we again and yeah, connect it, and then you can see how it looks from the inside. Okay. So this is what we prepared. This is a very cheap system. It only costed us $33 when we are doing like one print at a time. If we do it at scale, it might even not cost us $2 to print it. It also weighs only 140 grams, which is also like much more lighter than the smartphone that we are using. Okay. Any questions so far? I'll have some water for.
If you have any question, then you can raise your hand or type in the chat box.
Okay. And this time I'm going like really, really slow. So hopefully things are more clear. Okay. Yeah.
There is one question here in chat box.
How AI is used here. I'll come to that. I'll come to that. Yeah. Maybe in the next two slides it will be clear. Okay. So after collecting some data with our Placido attachment, we found almost 40% of the data was not good, what was not of good quality. Either it was out of focus, it was blurry, and for even when the image quality was good, the final output of the heat map was not matching the ground truth. So we did some deeper analysis, and what we found was that there are two kind of error that were happening, and both of these were misalignment error. Okay. So it is interesting to note here that if the reference axis, that is the axis of the cornea, aligns with the principal axis, which is the axis between the camera and the eye. So if these two axes are in alignment with each other, in that case, you will be able to get a very good image, which is like this. Okay. However, when the axes are not aligned, let's say that two things can happen. There could be an offset when this is like this, like it is up and down, or it could be like this. Okay, in either of them, so there could be a tilt or there could be an offset. Either of them can actually result in these kind of wrong heat map, even for a normal or a healthy eye. So what we did was that we actually created a simulation environment. Okay. And before that, like why actually this is happening. Okay. So what happens in the medical grade topographer, there is a chin and headrest. So your chin and head are fixed and then the device is like here. However, in our case, it is completely portable. You can just put it here and so your hand can move, your somebody's head can move, and all of that can result in these kind of misalignment. Okay. To fix these problems, we actually created a simulation environment to study and replicate these erroneous situations. And what we found was that these misalignment are very sensitive. Like even for a 3 millimeter of tilt, it can result in 15% error. Okay. So now to fix these problems, we added AI. Okay. So our app, so the Android app that we built, it has some on-device image processing. Okay. And what it does is that it not only checks for simple exposure and sharpness of the image, but most importantly, it automatically captures an image when the two axes are well aligned with each other. So you just have to keep your phone and move it till the two axes are alignment with each other and just clicks an image. Right. So with that, even a minimally trained person can capture very high quality Maya images. And this feature actually helps us to reduce that discard image rate from 40% to 10%. So here is our video of that application in action. Okay, so you can see that like the this is the view from the smartphone camera, and you can see as soon as there is the alignment, it will automatically capture three images. Click, click, click. Okay, and now you can see that this is how the captured image looks like. Okay. So if I move here, so there are two things which are happening here. There is actually a blue circle on the outside and there is a red here. So the blue circle and the red are actually at the center of that blue circle. It automatically does the capture. So this is where we do like on-device image processing to do automatic capture. Okay. Not only that, the heat map generation pipeline is also very critical. Okay, so now we have a very high quality Meyer image, but we have to convert that into what we call as topography heat maps. Or there are two kind of heat maps. One is the axial heat map, the another one is a tangential heat map. So we output both of them. So let us go through how that works. Okay. So the firstly, we just the captured image is actually simply cropped by identifying the center of the mire. For identifying the center, we actually use a UNet based DL model, and the cropped image is then converted into a grayscale. Okay. So as you can see that the eyelashes are covering part of the mires, we use an image enhancement algorithm to fill these gaps. Okay. And you can see like there are eyelashes at the bottom, but and so that might be causing gaps here. So we use the image enhancement, and this algorithm is actually based on the fingerprint detection algorithm. So when you do a fingerprint on those reader or even for your Aadhaar card, so we use a similar algorithm here to actually enhance the image quality. We also add anti-aliasing, okay, to get rid of those noises due to the low resolution of the cropped image. Okay. Again, this is a problem because we are using a commercial smartphone camera that we have to deal with all of this. And the medical devices use a very high grade custom camera for capturing such an image. Okay. Once these Myers are identified, and we use something called as the arc step method to reconstruct the 3D surface points of the cornea over which we fit a smooth surface using Zernike polynomial to obtain the curvature of the cornea. So this arc step actually helps us with the 3D print attachment size of it and the working distance, which is the distance between the eye and the camera. You can actually convert this image from a 2D to a 3D surface. And then because we know that it is a eye surface, we can put a we can what do you call it like a surface fitting algorithm, which is using this called something called as Zernike polynomial. You can get the curvature of the cornea. And now once you have the curvature of this surface, you can convert it into any kind of curvature heat map, either an axial map, tangential map, and any other value. Okay. This is, I think, fairly complex. A lot more detail is put in a research paper. So yeah. Now I'll talk to you something which is another kind of error which was very intriguing to us. Okay. So in the heat map generation, this working distance computation, as I told you, is very hard and it is also very, very critical. So it is the distance. The working distance is the distance between the smartphone camera and the apex of the cornea. So even for a healthy eye, a wrong working distance can result in incorrect keratoconus heat map. And also it is very sensitive. Even like a 2 millimeter error in working distance computation can result in 100% error. Okay. And also, as we know that due to the difference in the face structure, with people having either protruding bones above the eye, the working distance can vary even across individual. Okay, you can see here like some people have a what do they call it like deep socket eye or deep seated eye. Other one have like more protruding eyes. So even when you put the device over it, it can result in like you don't know where the exact surface of the eye is. So it's very hard to find it. Okay. Again, medical grade topographers have specialized hardware to measure this distance. They have like IR cameras, which actually there are two cameras on the top and on the bottom, and both of them where they align together, they find the working distance. So, but we don't have those kind of hardware in our system. So, and also we wanted to build a low cost device. So hence we relied on image processing algorithm to compute this working distance from the captured images. So I'll just talk to you about that and hope you're able to get it. Okay. So the working distance is basically the sum of the distance between the gap base, which is the distance between the camera and the base of this Placido disk, plus the Placido length, which is the length of this Placido disk, plus the gap top, which is the distance between the top of the Placido and the eye. In this case, this gap top can also be negative because your eye can go inside the Placido disk. Okay. So all of these three, like out of these three, Placido length is always constant. Gap base is also always constant because that is fixed. Only gap top is the one which can actually change your working distance. Okay. So in this case, we used two properties of the eye. One is that the radius of a human cornea is almost similar across the world. Okay. So the cornea length radius is 7.779 mm plus minus 0.2 mm. Okay. So this is good news for us. And second, even in advanced keratoconus case, the distortion mainly happen only on the sideline. The central region actually remains distortion free. So this implies that for a given gap top value, the radius of the Maya reflection in the outer region is same across the patient. Oh, sorry, I said the opposite. The distortion mainly happen in the central region and the outside region remains distortion free. As you can see, like the conical thing only happens at the center. Okay. So once we know a given like this gap top value, the radius of the Maya reflecting the outer region is same across the patient. Okay. So we can actually do a 1:1 mapping between the gap top value and the radius of the outer Maya. Okay. So with that, to learn this mapping, again, we use a simulation environment and we trained a simple regression model to fit this. So now for every outer radius, we know that what is the working distance or what is the gap top value. And that was being used in our system to calculate the working distance. Okay. We evaluated the smart KC system with more than 100 eyes from around 60 patients at the Sankrai hospital. One third of these patients have keratoconus, as you can see here. We asked four ophthalmologists to rate a curvature heat map, either generated by a smart KC, which is our system, or generated by Opticon Keratron, which is a medical grade corneal topographer. Okay, into one of these four rating that it is either it is a keratoconus image or it is a non-keratoconus case, or they were not sure and asked us to retake. So there are only three on these three they have to do a rating, and the rating was done by four different doctors individually. And here is the qualitative result, how it looks like. So you can see like on the left hand side, we have the Keratron, which is our device, Meyer images and the heat maps. On the right hand side, we have the smart key, sorry, all wrong. Okay. The Keratron is the medical device. So here it is the medical grade device, heat map and the curvature map. On the right hand side, we have the smart KC, which is our device, our Meyer image and our heat map. And you can see that like our heat map here looks very similar to the ground truth heat map. Okay. And the first two are for keratoconus case. The last one is a non-keratoconus case. Okay. Now going over the accuracy result for each of the doctor, I have reported numbers here. Then there is the overall number. And many of you would be aware of what is the sensitivity and specificity. So sensitivity is nothing. It is the ability of a test to correctly identify people with keratoconus, while specificity is the test to identify people without keratoconus. So in this case, Smart KC was able to achieve around or above 92% of each of these values across the doctors. And Keratron, which is the medical grade, the sensitivity was 100%. So they were able to identify all people with keratoconus, but they were also have a lot of false positive here. You can see only 64% specificity. Okay, so a lot of her in our case, we are not 100% here. So our system, Smart KC, actually missed a few cases. Okay, basically, a few doctors put a few of the keratoconus cases as a non-keratoconus case using our system. Okay, so let us go over these error cases to understand what's still a problem in our system. So you can see that this is the image where a keratron gives such an image. So you can see that the orangish reddish region here says that this is the keratoconus. However, in our case, we've got an image which is mostly green. It makes like this is a non-keratoconus case. Why this mainly happened? Because the poor quality of the image. If you look at the quality here, you can see that like there is some disturbance here which may be caused due to the tear film. Okay, and now we are working on figuring out ways to detect this kind of tear film based poor quality images. Okay. However, in this case of Keratron, you see this like, oh, this image is all red, which is like, it is really keratoconus. And in our case, we got like a pretty green image. However, this is actually a non-keratoconus case. So why this failed here for Keratron, which is the medical device? That the keratron image, the doctor said that is it failed because it is not limbus to limbus. So limbus is basically this region between the cornea and the sclera. So this limbus to limbus, the images should have been, which is also not the case in R. But keratron actually uses this limbus to limbus to identify the working distance. In our case, we use the last 2 miles to identify the working distance. And because that working distance error in keratron, the final output is wrong. But in our case, the computation was correct. So hence the final output is correct. Okay. Finally, our goal with any of these systems, like including smart KC or detector, which is for dry eye diagnosis, or auto refractor, that every child in school can be screened 4 times a day by a teacher to check for early case of keratoconus. Okay. And not only that, community health workers can do similar screening, and even somato personnel, like delivery personnel, can do a home-to-home checkup in low-income communities in urban and semi-urban India. Okay. So hence we want to make healthcare accessible, and this is one way to go about it. Thank you. Yeah. Any question?
So now participants can ask the questions by raising their hands or typing in the chat box,
Mhm.
or they can unmute and then ask.
Yeah, I think that's a good question by Arshi here. Yeah, it can definitely help in chronic disease management, like diabetes, hypertension. Definitely, it can. Uh, yeah, um, it can, like the way you said it, it can suggest the diet plan. Medicine, we are hesitant to provide that kind of information because that's usually, I think, a hard thing. So we don't allow it to do any kind of symptom checking or medicine. All that it will just give you, I don't know answer, and then the doctor has to fix those answer. Okay. Yeah, because I think in India also now medical legal is a big thing. So they don't want any kind of lawsuit because of these chatbot information. Definitely, it can provide specific medication or symptom detection or disease identification. It, yeah, it won't do that. Yeah. Yes, in the diet detection, again, it uses image processing. Like as I told you, there is a video processing there. So once the images are being captured, there is a. By the way, I'll just give you some more context because this dry I think came a second time, so I will just give you some more context here. So the dryness in the eye. Very recently we have a second paper on it. So the initial method that I told you was that blinking thing and the oil over the water kind of a thing. The color of the eye was able to diagnose it. But very recently, what we did was that we actually asked people, we actually used the same smart KC attachment and recorded a video of like a 30-second video of people's eye. And what we found was that the rings here actually break after a few seconds, and that is called as the T-but time, which is a tear breakup time, and that is actually visible in these ring breakup. And that is actually a gold standard for measuring dry eye. So what they called as T-but, there is something called as NIBUT, which is non-invasive tear breakup time. So using that method, so basically we have a now video processing pipeline which just takes these videos as input, like the smart KC device captured videos as input, and it tells you like what was the time at which all places the tear, basically these rings actually broke, and that is actually the tear breakup time. And if the tear breaks, so if you blink the eye and the tear breaks before 10 seconds, then you have dryness in the eye. If it takes more than 10 seconds, then you are a healthy eye. So we are using that algorithm now. Okay, so this is a slightly older deck, and yeah, but there's a paper called as Detector, which just recently got published, and there we are using the new approach. Yeah. Again, there is a video processing pipeline to identify that. Yeah, and the details are again in the paper. Hmm.
Okay, any other question from the participant side?
There is one more question I can see. How can you ensure about the accuracy of the chatbot? So the accuracy is ensured mainly using the expert in the loop. So it is the doctor who is checking every answer and ensuring that it is giving an accurate answer. The LM will hallucinate, it will make errors, and there is no way to do that. Even if you have like a maker checker model where every answer is checked by a SLM, like a small language model, then also like both of them can make mistakes. So the only way to give a correct answer is to have a expert or a medical professional to verify these answers. Okay. We have a few ways to reduce the workload on the doctor so that they don't have to like for a simple question, they don't have to intervene. But what like yeah, they we still have need to have them. Yeah. Uh, Discover the reliability of dependence on of AI in health. Sorry, I didn't get the question.
There is
Reliability of
one more question above that.
okay, let me answer that first. Is the system capable of detecting other diseases such as retinopathy or cataract? No, no, no. So each of these system is being built for a particular uh, disease. Okay, like smart case is only for keratoconus. Like the detector is only for dry eye disease. Uh, Retinopathy, yeah, I don't have anything on retinopathy or for cataract. Yeah, so I've not worked on those diseases, but every system is only for a single disease. Yeah. In our case, like yeah, smart KC was also used for diagnosing dry eye, so it just happened. That was not the initial approach. But what we found was that it can also be used for dry, and hence we did that. However, the whole video processing pipeline is very different for dry eye disease detection compared to the keratoconus detection. Okay.
Maybe he's asking, discuss about the reliability of dependence of AI in healthcare department. How AI is reliable for the healthcare department? I think he's asking this generic question.
Yeah, sorry, I don't know. I'm still quite unsure. Okay. Is it safe for mankind to use AI for surgery? Uh, there are robotic surgery which happens nowadays, and it is actually very highly safe. That's why they are doing it. So yeah, sure. AI for you can those robotic surgery you can say it is AI that is being used in surgery. And they are usually way more expensive, with very minimal recovery time. Uh, yeah, there is still a doctor who is involved in the process, but the robotic arms are the one who are actually doing the surgery. Okay. Hmm. Yeah, all of these are open source projects. Even the whole of Smart KC that I talked about has been open source. Even Detector, the dry disease one, we are in the process of open sourcing it. And all the cataract bot, Asha bot, the base platform, which is the build your own expert bot, BEOP, that is also open sourced. Yeah. So if you go to github.com/Microsoft, you can find all of them. Yeah. Can standing for Smart AI Resource Assistant for Health, SARA, use advanced language models can possibly. I don't know what is this. I have no idea. What is SARA? Sorry, I think it is not relevant to my talk. Yeah. Hmm.
Any other question from the participants? Sure.
Which algorithm are you using for achieving what? In which case, sorry.
Tell
Parvez,
me which problem, specific problem. Can you type for which specific problem you are trying to ask? There is one more question.
how do XAI system can? Okay, okay, I'm reading Narsimhan question. How do XAI system can bring the transparency in generative AI model? Normally, image data we apply CAM, grad CAM, feature shapes like techniques we use feature-based, image-based model. Transparency generative AI model. So see, okay, design a chatbot. Okay. Good. Okay, so one at a time. There are a few questions. I'll just answer Narasimhan question about the XAI system. So right now there is no way to explain the answer from a generative AI model. So LLMs don't have a equivalent of like a GradCam that you can use. That what features were actually being used to get to a particular answer. Okay, or so hence there is no way. I think only you can ask it more question and it can give justification. You can ask it like give you a rationale. It can give you a rationale why it has come to a solution. I think the more standard approach that is being followed across is the maker checker model, where actually every answer, like I think definitely you all must be aware of like yeah, think step by step, wherein you ask it or like take a deep breath. So all of these prompts have been found to work better. But the other thing that people do is that like when the answer is given by one LLM, it new LLM instance is being asked like, oh, this is a question, this is the answer. Is this a correct answer? And if not, give me a rationale for it. So that kind of a maker checker model is usually what being used. But again, none of this is adding to the explainability of the answer. You can always ask the bot or ask the LM what is the rationale behind the answer, and it will automatically give you a written description of it. And that is the only explainability you get. But again, it can even either hallucinate in the answer or hallucinate in the generation of the explainability of that answer. Okay. So everything has to be taken with a pinch of salt. Yeah. Moving on to Ashi's question, in what ways can Gen AI personalize treatment plans based on the patient's medical history and genetic data? I have not worked at it because as Microsoft employee, we don't have access to these medical history or genetic data of the end user. Because these are again like because the PI information is very deeply embedded in them. PI is like a personally identifiable information is deeply embedded in these data. So we don't have access to it. So I've not worked on it. But there has been work around the world on like how personalized treatment can be given using Gen AI. Yeah, you can just like check it on maybe on yeah no, online. Yeah. Um, Sir, which algorithm is used to design the chatbot? So right now I think designing the chatbot is more of a system building exercise. All of these components, like the language technology component, the OpenAI, like the GPT, all of these models are available. Okay, and hence like yeah, you don't have to like the algorithm. But I don't think there is a specific algorithm. There are a lot of problems that we face by building the system, as I told you, like the transcription challenge, translation challenge, even the knowledge base updation challenge, where for each of them we do have a complex algorithm to take care of each of them. But just to build like a box, like a basically out of the box, like a simple chatbot, you can just build it using any of the existing technology. Yeah, you don't need an algorithm for it. Uh, how is real-time data from ANN processed and updated into the chatbot response system? So they told you like yeah, just ANM's any answer from ANM, like all those answer. I think I talked about that. Like so, there is a pipeline in place. So we wait for more than five answers from ANM. We keep on adding more and more ANM, or we can keep on sending the same question to more and more ANM until then we receive five responses out when we receive all these five responses, we it runs through a pipeline where first we check for the relevance of the answer. So we send the question answer pair to a LLM, ask whether the answer is relevant to this question or not, yes or no. If we say no, then we just remove those answers. Second, we check like if there is a conflict or there is a contradiction between these answers. So let's say one ANM has said X, while another ANM has said Y, the another has said Y double dash, the another has said Y triple dash. In that case, we know that the X is not in line with what y dash and y double dash have been saying. In that case, we do a majority voting, and if a majority of them aligns with a particular answer, we just use that. So we just combine all now y dash and y double dash, which are not contradicting each other. So we combine the responses together and send that back to the ASHA worker as an answer. All of this is happening using multiple Gen AI LM prompting. Okay. There is no like these writing this prompt engineering in itself is a task these days, but it is very much reliant on it because that works very well. Okay, for all this text-based task, yeah, LM do a pretty good job. Okay. Mm, yeah. So that's just the question. Good question. Five answer is not enough from ENM for majority voting. So the way it works is actually more complex. Just like a simplistic version of it. Many times we also have like some threshold that three or more ANM should have a similar answer. So let's say out of these five, four of them have given like a irrelevant answer, like just hi, good morning. So in that case, we send it out to more people to like 20 more ANMs to get a response. And also let's say like at the end of the five of them, like one is irrelevant and two of them are contradicting each other. So then we again add more enums to the system. So right now threshold is that three valid answer which are in line with each other. They are not contradicting. So we keep on going through this process until we receive that. Okay. And how that number of three was decided? Uh, yeah, I think that was just trial and error and based on our conversation with the NGO partner. How that number of five was decided was that like we mostly found like yeah, even getting like two responses from like two different ANMs is rather hard. So within 1 hour time, we also wanted to give a answer in a time bound manner. So in 1 hour we are getting like around five responses. It's not like, yeah, 5 is a good number because after an hour we should at least try to generate an answer and give it to the Asha. Okay, so hence kept it 5. But all of these are parameters. Okay, that this is a very configurable thing. Let's say tomorrow somebody says that we need 7 answers, we need 10 answers, we need 2 answers. We can easily just change a number and that's it. Okay, so yeah. What algorithm is used for majority voting? How does it handle cases where opinions are evenly split? I think I already answered the second one. If the opinions are evenly split, we add more ANMs so that we can get a definite majority. Uh, Algorithm for majority voting is also very, it's like a combination of a small Python code along with the LLM prompting. Okay. So we once the LLM defines or identifies that there is a conflict between these two kind of answer. Let's say answer one answer says that like the example I showed that there is no side effect, while the other three are saying there are some side effect. So automatically now we have like some code inside the prompt which says that or some function inside the prompt says that like now do you do a count, like for who people who are saying X, you count each of them one, two, three. People who are saying Y, you count one, two, three. People who are saying Z, you count one, two, three. And then it just gives us a count that like, oh, this many number of people have said this many have said this many have said this. And then we have algorithm which runs which say that like, oh, if it has reached the majority, you use all of these responses to find the final answer. If it doesn't, then just add more ANMs to the loop. Okay.
Any other question? I think all are answered.
Yes.
Algorithm is used for good. Okay. So I think we should conclude the session here. So Pinky, please conclude the session.
Thank you, everyone. Bye
Okay,
bye.
sir. First of all, give a huge virtual round of applause to Dr. Mohit Jain. I sincerely thank you, Dr. Mohit Jain, for delivering an insightful session on how generative AI is transforming healthcare, particularly through AI driven chatbot and automation to save time. Your valuable insight on how chatbot enhance patients' engagement, streamline consultation, and assist healthcare professionals in reducing workload were truly enlightening. We truly appreciate your time and efforts in sharing your knowledge with us. Looking forward to more much engaging discussions. Thank you so much, sir.
Thank you.
Okay,
Bye
thank you,
bye.
Mohit, for giving them such nice presentation and discuss the work which is going on Microsoft and answering all the queries very well. Definitely, it is very useful for all the participants. Thank you very much.
Sure. Sure.
Okay,
Thank you,
bye bye.
Dhiraj.
Bye
Bye
bye.
bye.
We
So
will
now
continue our next session once our speaker will join.
speaker is here, but we will start our session at 5. Okay.
Yeah,
So Abhay,
and
I think are you here?
yeah, I'm here.
So meanwhile, you can check by sharing the slide. So as
Okay,
per schedule, we will start at 5 after 5 minutes. So meanwhile, you can check your slides are visible or movable.
can you
Yes, it
guys
is
see
visible.
it?
Yes, it is visible.
And let me see the presentation.
Just
Can you
move
see the
one or
full
two
screen?
pages. Yeah. Yeah. Can you move one or two slides so that we can see is it moving or not?
Is it
Yeah,
going
it is
forward?
moving. It is moving.
Okay,
So I think Pinky, we can start now. If everything is ready, please start.
Okay, sir. So should I start now?
Yeah.
Okay. Let's move to the next session with our keynote speaker, Dr. Abhay Gupta, who will be enlightening us on building Gen AI based system. It's our privilege to have with us Dr. Abhay Gupta is an accomplished economist, data scientist, and technology leader with over 2 decades of expertise spanning economical model, AI driven analytics, sustainability, and policy research. He has successfully led multi million dollar projects across the public and private sector, specializing in data driven decision making, ECG strategies, and AI application for economic forecasting and business optimization. As director of Efficient World, Dr. Gupta has spearheaded over 20 projects focused on economic growth, sustainability, and climate resilience, developing machine learning solution and analyze vast data set for optimizing decision making. Previously, as a lead consultant at the European Investment Bank, he managed a portfolio of 30 plus development projects worth 800 million, publishing influential studies on sustainable investment strategies. His leadership extends to the OECD, where he developed policy framework for global competitiveness and innovation. Beyond economics, Dr. Gupta has held executive roles in AI and data science, including VP of Data and AI at Skyhive and head of product at Lung System, where he developed enterprise AI/ML solution for workforce reskilling and strategic business planning. He is also an active contributor to international standardization efforts, serving on technical committees for ISO, Standard Council of Canada at and the International Electrotechnical Commission in the fields of AI, sustainability, and management consulting. Dr. Gupta holds a PhD in economics from the University of British Columbia and engineering degree from IIT Kanpur and executive education credentials from Harvard Kennedy Schools and Columbia Business School. A, a prolific researcher, he has published over 250 reports and papers shaping global discussion on economic development, AI application, and sustainable policy design. Now, I invite Dr. Abhay Gupta to take over the session and share their valuable insights with us. Over to you, Dr. Abhay Gupta, sir.
So thank you so much for such kind introduction. Uh, Hello, everyone. So you have been attending this session. So I thought that rather than giving you something that you've already seen, since this is the last session, I will give you a high-level overview on how to build a model and focus more on things that sometimes might be overlooked when you are actually focusing too much in the detail. So maybe let me go through the slides. And I think the way I will go about is I will do the presentation and leave the questions for the end. But if you have anything urgent, maybe you can type it in chat. So the session objectives are understanding Gen AI. I mean, people have been using these words and then you keep hearing these words. It's always good to understand what exactly do we mean by Gen AI. And then how to build a AI-based system. So I will go about what are the steps involved, even though like some of them might be already clear. I will go through step by step. Then exploring the real-world applications. And then one thing that gets missed in technical details is what are the ethical challenges, what are the regulatory challenges. I'll talk about that as well. And then I will talk about the like practical tools that are available right now. So ChatGPT is one of the most popular one. I will go through some of the most popular tools and then what are the use cases that can be built using those tools and real world applications. So again, I mean, this is the agenda outline, overview of generative AI, then the system architecture. How does like what are the fundamental building blocks of creating your own Gen AI models? And again, I mean, not everybody will create their own. Sometimes it's better to use one of the existing models. So we'll explore what are the popular models out there and what kind of applications they are being used at and how you can use them to create your own model. What are the development workflows and challenges and best practices. And in the last, at the end, I'll talk about some of the ethical concern and how does future look like or what are the expectations and worries about future of generative AI. So what is generative AI? Again, I mean, the word has been in use for quite some time now. So it refers to artificial intelligence model that creates new content such as text, image, audio, or even code. And again, I mean, if you go back, what is AI? Like, for example, now it's being something being used even to talk about automation. So AI is something that actually starts to think like a human. So an automation is not an AI. If you are doing rule-based engine, that's not usually an AI. Artificial intelligence means a model that can actually work beyond the original set of instructions. And in particular, generative AI, it uses those instructions to create new content. So how it works, you use deep learning models, and we'll talk about some of the models on vast data set. And once you train that model, you know what kind of parameters to use to create a new set of content. So it generates content probabilistically, meaning each output is unique, but it follows the pattern from the earlier data set. And you have seen the example if you have used ChatGPT or any of the image creation software or image creation tools. So what are the characteristics? It generates human-like content, and this is where it's different than rule-based or simple engine. It thinks on its own, so it creates a content that it has not seen before, and using the earlier data. And comparison with traditional AI. Traditional AI focuses on prediction, like if you are doing analysis of data and trying to predict what would happen. It will use classification algorithm or predictive modeling. But in generative AI, in addition to answering questions, it actually generates data, text, code, images for yourself, which is not the replica, but uses the existing data to create new data. So most popular, they are some of the most popular generative AI models. One is like number one is GANs. So they comprises of two neural networks. One is a generator and the other one is discriminator. Generator creates fake data and discriminator distinguishes real from fake data. And the benefit of this type of network is it improves by competing against these two networks. So, and this is how you create actually realistic data that uh, is more likely to be real. So one use case is image generations. If you look at some of the popular chat GPT's tool out there, like chat GPT type tools out there, some of the models might be using one of these popular models in background. So image generation, air generator, artwork, deepfake creations, realistic avatars. Then the other one you have is auto encoders. You use probabilistic encoding to generate data, and even after like you are creating a new data, it retains the essential features of the model. So they focus on controlled generation of output, for example, image reconstructions. So you don't go beyond that defined scope, data augmentation, feature extraction. And then you have the transformers that are used in chatbots, like use self-attention mechanism and process the text in parallel. So you write a prompt, it looks at the matching set of earlier neural network where it finds that, okay, this is the uh, past data that I've seen that is similar to the prompt, and then it generates text summarization, coding assistant, or conversations. And this is used in chatbots, AI writing assistant. Then the fourth one that's also quite popular is diffusion models, and we see it in like tools like DALI and other image generation tools. So it is used to gradually reduce the noise. So what are some of the applications? And I've talked about some of them already. You have chatbots, you have AI-assisted writing for Grammarly, Jasper. Some of them are using it internally, so you don't think of them as an AI tool, but they are using AI in the background when they're suggesting you, okay, this is the way you can rewrite this sentence or paragraph. And then you have code generation. So code generation started as autocomplete, but now in addition to suggesting you how to improve your code, they are actually telling you how to write the whole code block if you explain the functionality that you want. Tools like GitHub and Copilot can generate the whole code, and we'll talk about some of them later in detail. Then summarization and translation. And another major like type of content that's created is image. So you have AI-powered art, like tools like Midjourney, DALL-E. Then you have product design and advertisement. So you can actually create, even LinkedIn has these kind of features where you, if you want to create a banner, you describe what the article is about or what do you want. So you do like type a tagline, it tries to find or generate image that satisfies those criteria. Then you have music and video generations. For example, OpenAI Jukebox is there. And you can actually create a video synthesis and animation. And there are some applications in healthcare, and you just saw one of them. But there are like more sophisticated places where it's being used. For example, AI-driven drug discovery, which kind of protein structures are more likely to solve a particular problem you are looking for. And I mean, medical image enhancement was the case that you just saw, AI-powered MRI scan. And then you also have, like, for example, you create a structural database of question and answers that are based on documents from description of manufacturers from these drug manufacturers. You also add the database from WebMD and other tools, and then it actually generates personalized health advice. So you tell it your symptoms, and it tries to find out what kind of relevant information you are looking for. And like, for example, even in the next category is education and research, is being used by tutoring system like Khan Academy, where it tries to find out what kind of concepts you are weak in, and then it tries to suggest to you that, okay, this is what actually you should be studying. It actually goes to your answers if you have given a step-by-step like details, how you derive that answer, and tries to find out where you went wrong. These kind of personalized learning paths. So how does an AI system look like? It consists of multiple layers, and these are some of the like major categories you can put out. You have a data layer, which consists of data collections. You gather database, and sometimes you already have the database built in, or you have APIs that pulls in the real data. It could have structured data or unstructured data. Then you have to store it somewhere. So like cloud storage, like you can use it on AWS or Google Cloud Storage. Some people, I mean, they use it on local machine, but then again, it depends on what kind of model you are trying to build and what is going to be the application. Finally, how will you deploy it? And that's why, I mean, it's an iterative process. Sometimes you start while having one set of structure in mind, but when you later on go and build the data and try to apply it, you might have to change the deployment altogether. And before you start training your model, you have to make sure that the data is ready to be trained. So you go through pre-processing and augmentation. So what you do is find out missing values, whether it is like structured properly. Even if it is unstructured data, does it have proper instructions that can be extracted from that, right? Synthetic variations. The second layer is model layer. So what kind of model to choose? Again, it depends on what you are going to use it for. And I mean, there are like now some tools which allow you to create multiple types of text, and they are called like multiple channels. For example, you can create text and images. So you might be using multiple models, or you might be serving them at the application level. So once you have chosen the architecture, you have to like use the data to train and fine tune the model. So by training, we means, let's say you have a neural network. So what is going to be the basically values of those like all those nodes and branches. So again, like finally you do, and I will go into detail what it all means. You do inference optimization. So if you need to fine tune, for example, like what kind of parameters you should put more value on, whether this one is actually the right inference or not. So it could be AI assisted inference optimization or human assisted. And you might have seen there's a company called Scaled AI that became a multi-billion-dollar company. All it did was hired people in developing countries to help train the data for companies like Microsoft, OpenAI, and all these big giants. So this is where they used humans to make sure that the inference of the data that was being identified as a particular image was correct or not. And finally, you have application layers. Right? How do you provide an interface for people to use this model? So once you know that the model is trained well enough, where it's making right prediction, right inferences, you can try to deploy it. And then, I mean, you have to find out whether you want to deploy it on a private server, whether you want to have it on cloud where people can access it through applications or like mobile application. And finally, security and access control. The first layer I talked about it, like one of the most important part is data ingestion and pre-processing. So the quality of your model will depend on the kind of data that was used, training data. So training data could be structured or unstructured. It has to be labeled like this is what it is, right? For example, if you have images that this is a dog, this is a cat, these kind of things. So if you are building your own model, where do you get the data? So there are a lot of open source data sets, and there are some examples that you can even, for text, you can have probably their common crawl data, you have Wikipedia, you can have web scraping. So a couple of the things that you have to worry about is what are the legal considerations? And this is what many of the companies are facing right now. For example, one of the software company, Perplexity, is being sued by New York Times because they use the data and the answers that are coming. It looks like that they uh, are actually using New York Times data, and then they are saying that, hey, you did not take my permission? How is the revenue distributed? And these kind of considerations come into picture. And again, then you could have a user-generated content itself. So, for example, there is this concept of RAG models where people are using their own internal data sets. So let's say in a big companies like McKinsey, etc., you will have a lot of documents that are being created. So you want to train a model on that. So what are some of the challenges in data collection? So first is data bias. So you want to make sure that the model is general enough to answer queries or generate text that goes beyond the data. And that's the whole point of generative AI. So if your training data itself is biased, that bias will remain. And this is something that many of the uh, like researchers have found that when it comes to, let's say, models, they are answering questions with a certain type of political leaning. And people are saying it might be because of the model, or it might be because of the data that was used to train them. So this is something that will, again, that second part, we talked about it a bit, like if you're scraping data, if you're using data, are you allowed to use that? The other one is, are you allowed to make inference on that? And I will talk about a couple of things later on, but one example could be that, let's say, for example, in US, they are using this data to predict what would be the best way to assign a credit score to somebody, right? And if the data itself is biased and it gives you lower credit score to Hispanics and blacks, the prediction model of this one kind of models, even using AI, will have those biases. And then if somebody doesn't like it, right, they can have a lawsuit against you saying that you are discriminating against us. So these kind of things that you have to worry about. So we'll talk about those ethical concerns later in the presentation. And scalability, right? So what kind of data structure to use? Should you basically use training data that is already being used? Should you keep throwing it and only save the inferences, or should you keep saving the old data even when you are just improving the model? These kind of consideration. And data cleaning and pre-processing, how to miss, these are some of the issues that you have to worry about. Missing values, right? What are the techniques? Like if you don't have the value, what do you do? How do you make sure that it doesn't make wrong inference just because of missing values? So there are some techniques, for example, imputation. You can either remove the incomplete data altogether, or you can impute the value by using some rules of thumbs or using some internal model. Then you have normalization, tokenization, noise reductions, and finally data augmentation and enhancement. So let's say you don't have enough data, what do you do? So like to make sure that your model is trained well enough, you can actually create synthetic data. And for numerical data, there are techniques, and even for text data, there are techniques, right, how to generate synthetic data. And these are some of the techniques that you can have. Data augmentation to make sure that adversarial attack doesn't happen, and we'll talk about this later on. And you can combine text and image for richer training data. So the second consideration, if you're building your own model, is basically training infrastructure. And this is one of the entry barriers that many people talk about, that only big companies are able to create it. And this is why, let's say, China has a model like DeepSeek, even though they did not have such a big training infrastructure. So, I mean, so this is something that a lot of companies or even research institutions are working to reduce this cost, that you should not be needing that much infrastructure to train your model. For example, hardware considerations, CPUs, GPUs, and tensor processing unit. And NVIDIA became a $1 trillion company because everybody was thinking that this is the easiest way to improve the training infrastructure by buying a lot more chips. Then the second consideration is whether you should host it on cloud or should you do on-premise trainings. So AWS, Azure, and Google Cloud. So there are pros and cons. These are very scalable and cost effective if you want to scale it up only during training phases. So you don't have to buy servers just for a few months or a couple of years. But the issues are that you have to rely on the infrastructure, network infrastructure, and on latency issues. The other one is data security concern. And one thing is not mentioned here, but I talk about later on is jurisdiction, who owns that data. Right? Those kind of things are also you have to worry about. And the other side is you can do it on in-house on-premise. So you have more control data and lower cost in the long run, but in the short run, you have to have your own data centers. You have to spend a lot of money on building that infrastructure. And then the third part is distributors, training, and parallelism. So this is where you have to use computer science techniques to make sure that you have splitting data to reduce the requirement, improving the model. And this is where DeepSeek and all these people are saying that actually the initial expectation or initial requirement was too high. You don't need that fancy data set because you can improve the model itself to run it on a lower requirement of infrastructure. So which tools to use? Right? TensorFlow, these are some of the popular models, TensorFlow and PyTorch. Then you have Hugging Face Transformer. I think that's for Facebook made it open source. And then you have these tools that can help you with training the data. And this is what experiment I talked about, where you are actually using humans to help them label the data, make sure that the training data is free of biases during inference. So once the model is trained, it must be optimized for inference. So you do testing, you don't make it live without making sure that the result it's generating, it could be images it's generating, it could be the text it's generating, is actually valid. So you create a model inference pipeline. You could do it in batches or you could do in real time. Right? So you can process multiple queries at one time, or you can have like chatbot type of inference. So it's still not live, but you are testing it either by human or by using automated methods. And then once you have created that pipeline, that this is how I'm going to test the model's inference, you have to optimize it, because once it goes to deployment, it has to be scaled up, right? So then there are some techniques, for example, converting a model to 30-bit to 8-bit so that it can run on mobile devices, for example, if you're using that kind of deployment structure, using a large model to train a smaller model. That way it can deploy faster and run with a lower resource requirement. And then if you have unnecessary connections in neural network, you can actually remove them if it is not needed for the particular deployment and for making that inference. So those are the kind of things you improve during your inference testing. And the another consideration is trade-off between complexity and latency, right? Speed versus accuracy. It has to be fast enough and it has to be accurate. Like the bigger model you use or more fancy infrastructure you use will help with the speed and accuracy, but that's assuming that you have unlimited resources. But if you're working in real life, deploying your own model, you have to worry about these trade-offs. And then there are like hybrid approaches. You have lightweight models on mobile devices and complex model on cloud, so that you, based on the need, you can actually serve different consumers or different needs using different infrastructure. So how do you select which model? And this is one of the questions that many researchers or many practitioner asks. So again, it depends on multiple factors. First one is your requirement. Are you only are you going to generate multimodal text, images, everything, videos, or only one particular type of content? So its first consideration is suitability for data type. So you have text-based model for GPT, BERT, Llama. Then you have image-based model. Then you have multimodals, right? So these are already available, and many of them are open source. Some of them are require license if you want to make more than a particular number of queries, but these are available for anybody to use. Then the second thing you have to worry about is when deciding which model, right? What is the computational constraint? How is it going to be deployed, right? If you're deploying it on mobile phone, smartphone, right, you will have to pick up one of the lightweight models. If it is heavy model, you can only be running on computers. The other one is like model is going to be used on training data, right? Do you have enough data? I mean, if you are using a pre-trained model, does it fit the specific need, or do you need to customize it? For example, like there's a big company in Vancouver which is doing it for legal sector. So I mean, does the model uh, satisfy that need, that if I am going to pre-train it on a particular set of document, will it work properly, that kind of thing, versus training from scratch? These kind of consideration you have to worry about. Then cost is one of the most important concerns. The other one is ethics and bias. So many of these models, pre-trained model, if you're picking up, there are some of the biases that are already known. So you have to make sure that, like for example, I gave one example, and similarly, people are talking about some of the data models being having these fine-tuned parameters where it doesn't talk about a particular subject, or it present a partial view of one of the particular subjects. So if you already know it, then you might use some of the bias mitigation techniques by finding out more about that thing, and either you use additional data set to train it, or you modify it. And then you have this explainability. So one of the problem, depending on what kind of applications you are using it for, you might need something called explainability. It's why did model say that? What is the reason for this result? So I mean, we are talking about things that are going to be used for making real life decisions. So you have to know that, okay, why, for example, the case I gave you was one case, credit history. Then there is another use where people are using these AI models to predict which vehicles to stop. And if it is being trained on a particular data, it is more likely to stop, let's say, for police officers in US, they're stopping more black. So then they will say, oh, okay, is it like racially biased? Then you have to say, no, it's not the race that is being used, is because of the past instances of his crime. So that kind of thing. So you need to know why model is predicting something. Explainability and transparency becomes important depending on the situation. So like how do you deploy it? So the third part is, once you have pre-trained the data, you fine-tuned it, like you have to decide about like how will you deploy it? And this becomes a consideration when you're building your own model. So some of the things that you have to worry about is, like, for example, deployment environment. Is it going to be on cloud? And again, the consideration is scalability and cost effectiveness versus on-premise, where you have more control over data, but it requires a lot of hardware investment. And the other one is edge AI, whether you use a mixed approach where you run the AI models on like mobile devices, but some of the computations happens on your own cloud wherever you deployed it. Then the API-based deployment. So like for example, some of the applications, rather than giving final application, you might be using it as powering another application from it. So for example, let's say you are running a company which helps, the example that was given, people make a decision on particular topics. So rather than you building the application, you can just provide them this model-based services where they integrate their application with your AI. So it avoids the need for local compute power. You are running on your own cloud and providing them inference using API. So you can see that many of the like providers, they give you API calls rather than just using their applications. So if you're integrating businesses, then you can actually use chatbot without managing the infrastructure. Then the third aspect is containerization microservices. So you could be using models within a particular applications, right? So then at that point, you don't have to run the whole applications. That's another way to deploy it. So it reduces the operational overhead. You are displaying only a part of a whole application, which is powered by the one of these models. And the last part for deployment is strategy is the security consideration, data privacy. So for example, when you're generating text, is it going to say something that is not, that was a private data? Right? So when you scrape the data, and again, everything is linked. So while you are using a training data set, make sure that the data sets that are using are actually publicly available. You should not be training it with a personally identified information, because what if it actually leaks that data? And if that data is required to train it, make sure your model and during inference optimization, you are actually taking care of that. And the other one is unauthorized actions and API abuse, that they are actually using your resources to generate revenue for themselves. And again, this protecting model against poisoning attack, we'll talk about it a little bit more in detail, but this is something that you have to worry about while deploying the model. Then one more consideration is scaling and performance optimization. So you make sure that the Gen AI models, they perform well under high loads without excessive cost. And this is something that becomes more important if you're running a research facility and you make it live, and then people are actually, you are right open sourcing it, or you are asking it as a service where you don't even have resources. So then you have to worry about whether it will actually lead to a high excessive cost, because the cloud bills could run in hundreds of thousands of dollars if it is not properly customized or optimized. So there are some scaling strategies that you can use to make sure that you manage the cost well without compromising on performance. So you can use vertical scaling, you can add more computational power, or horizontal scaling, where rather than adding computational power to the same server, you actually deploy it on multiple servers or multiple instances to distribute work. And then you have to do load balancing, which this particular server to direct the request to. And then there are already established performance optimization techniques that you can use, that you can compress the model so that it doesn't require that much resources. So you can reduce the model size, or you can use pruning by removing the unnecessary parameters. You can use caching mechanism so that it doesn't have to do the computations again. So you can store them in database if it is known that there are some responses that will always be asked, that are more likely to be asked than others, so that you can save time. Then inference optimization, right? So make sure that if it is quite complex, whether the user is actually user is going to be needing that kind of complex inference or not. If he's asking for something simpler, you don't have to run the whole complex query and provide with that inference. Then like auto machine learning solutions. So you can use automatic tools. So for example, Google has these tools, Azure has tools where you can actually optimize the parameters. You don't have to provide a very detailed automation structure to do this. There are tools that are already available, so you don't have to reinvent the wheels. And another thing that you have to worry about is if the data is updated, right? For example, even for things like ChatGPT, if it was trained in 2022, every year it needs to be retrained. So how do you do that? You don't want to incur the whole cost again. So what kind of things that you have to make sure that you don't lose the old patterns that were done, so that you can introduce new patterns without rerunning the cost. And then the final consideration is online versus offline. You want to do it continuously, or you want to do it in batches? So how do you evaluate AI model performance before deploying it? So this is something that we have to worry about, especially if you are working in a sector where the results are going to be useful for some, and but where wrong results can have like real life impact. So this becomes more important. So assessing the performance of AI models, which actually required some of the matrices, and we'll talk about like you can see what kind of matrices we have. If you already know the data, we can actually find out whether what kind of performance the generated text has. So you have these measures where you can find out the generated text is actually performing better on these evaluation matrices or not. So you have perplexity measure for text. You have these text compared to human text. For example, like let's say as a teacher, you don't want people to use ChatGPT. There are tools who can actually find out using these measures whether it is generated by human or whether it's generated by ChatGPT. So these kind of tools have both types of usage to improve the model and make it more human-like, or you can use these parameters to find out whether a chat is generated by or a text is generated by tools like ChatGPT. So those kind of things, I mean, these evaluation matrices can be used in both ways. Again, depends on your requirement, whether you want to improve the model performance and make it better like human, or if you're working on the other side and writing an AI tool which can predict or which can determine whether that text is written by generative AI models. You have a structural similarity index. That's a similar like kind of idea, but it applies to images, whether it looks like a real image that was already in the database. So you can do automated evaluation as humans. And this is the example I gave of the company Scale.ai, and they helped a lot of early model developers in using these human in the loop kind of model verification and performance improvement. And the last part is explainability and interpretability. So let's say you have a bad result. What do you do after that, right? So how do you find out why model is making that kind of inference? Right? So there are techniques like SHAP and LIME, and then there are other ones. So then you debug the model, you identify the biases, and make sure that they can be improved. For example, hallucination, it creates facts which don't exist in generative AI outputs. So how do you fix for that? So I talked about it a little bit and gave some example, but this is a big concern, especially for policymakers and even business leaders. Right? What are ethics biases and what is responsible AI? So again, I mean, we are generating text, and since more and more users are relying on it, we need to make sure that these systems have fairness, transparency, and accountability. So let's say if things go wrong, I mean, with humans, you can say, oh, he was the one who made that decision. Who do we account that decision when it comes to models? Right? So what are the ethical challenges? The first one I talked about, bias in training data. Right. For example, even when it comes to model training, most of the text that is being used so far is in English, right? Even if you use translated text, there might be some biases, right? So the language is one concern. Then the past data has been only like
Is it paused? Hello, Abhay, can you hear me? Pinky, this session is paused. Can you confirm? Yeah, I think there is problem from his side.
Sir, your screen is not share, sir.
Yeah,
Hello
now
guys,
is it
can you hear
visible?
me?
Continue.
Okay, okay, yeah, okay. So looks like there was some issue with Teams. So you can see it?
Yes, we can see.
Okay, perfect. Yeah. So I was talking about this biases, right? So like there's biases that we have to worry about, and it can perpetuate the biases. So one of the things that we are doing as economists and as policymakers and as society, that we are fixing old biases. But if the training data itself is biased and people are now using that as the sources of truth or to generate new text, we will not fix those biases, or we have to make conscious effort to fix those biases. And this is something that many people not even like they're not even realizing that there's a risk for that. And this is actually something that a lot of policymakers are now starting to take notice. And the flip side of that is misinformation and deepfakes. For example, like you can create a fact that doesn't even that's not true. It could be because somebody on purpose did it, or it could be that it was on the training data. So you can actually have these kind of misinformation permanently built in, and then after a while, I mean, if the data is being generated by Gen AI and that data itself is being used by people, and then you like post it on internet and that data is again used to update the model, it becomes permanent. So that's a big risk. And then you have privacy violation, right? Unauthorized use of personal data. So no matter how careful you are, right, to ensure that it doesn't leak, it's better if while training itself that data is not used at all. And now Europe is also part, I mean, we'll talk about these like regulations, but who owns that data, right? So for if your data is used to train a model, do you get a say into that, or you can't say anything about that? These kind of things. So it's not only about privacy violation, it's also about who owns the data. So those kind of things are now getting into play. Then what can we do? Responsible AI. So what is responsible AI? Building and using a model in a way that doesn't that's quite fair and it doesn't perpetuate the old biases, these kind of things. So bias mitigation is one. So you can use data balancing. So if you already know that this kind of data is more, you can actually try to categorize the data that's being used in training and ensure that you have balanced data. Then you can, since you already have that kind of models, like you have these adversarial network, can use that technique. So let's say you can't do anything about the data, what's been used to train. Can you actually use the models to debias? So use adversarial model to use that kind of bias mitigation
तुमने
methods.
चेक किया है ये मार्क्स वगैरह सब शो कर रहा था?
मार्क्स वगैरह शो कर रहा है 40 मार्क्स के टोटल क्वेश्चन है सर।
मैं ये कह रहा हूँ तुमने जब टेस्ट किया था तो जब टेस्ट
So Anurag,
करते हैं तो आंसर से मैच करके मार्क्स जनरेट कर रहा है कि नहीं?
yeah, so let's continue.
ये मैसेज आ रहा है, हमने व्हाट्सएप भेजा, ये क्या टाइम के
So
साथ
sorry,
आएगा?
sir.
ऐसे
You
सब
can
चल होगा?
continue.
Okay, sure.
And just
So industry, like so example, this transparency and explainability, this is something that we have to make sure that like people are getting it, right? If you're using AI AI to make a decision for you or helping you make a decision, for example, the cases that we are talking about, right? If AI is determining whether you have cancer or not, these kind of things. So it's not only about like having a text generated that's more right wing or left wing. If it is going to be used for like real life, uh, actually life and death decisions, a doctor is using an AI tool to find out whether you have a cancer or not. You have to make sure that you know why it gave a wrong diagnosis, right? You have to worry about false positive and false negatives, right? Sometimes one type might be more relevant than another. So on that one, rather than throwing the model all away, if you know why it's doing it, maybe you can actually try to improve it, or later on also to help make sure that you are not persecuted or sued for a wrong case, right? That's the decision you have to make. So transparency and explainability. And then you have like a lot of regulation is coming in, both with respect to like data, like Europe has GPDR, then you also have AI Act, and in India is also following suit, where you are trying to find out who owns the data, what is the data being used for, what it can be basically not only used for, but did you take the permission for which purpose it was supposed to be collected? So even if you have collected the data, you cannot use it for a purpose that it was not originally intended for. So those kind of things are coming into play now. And one of the things that actually, as economists, we believe that the government should have least role to play unless it's important. So industry is also trying to self-regulate. So you are coming up with like you are seeing these guidelines. For example, Google came up with AI principle. I mean, these are some of the lists, but there are a lot of initiatives that are going on. IBM has AI ethics guidelines. IEEE has standards for AI. So now I'll talk about some of the real world case studies, and I mean you have seen or you have heard of them, and like you have OpenAI, ChatGPT, and DALL-E. ChatGPT is for text, and then DALL-E is for generating image. So what is the use case? You generate text and image for content creation. And what is the impact? So one of the things that we worry about as like policymakers or business leaders, that what's going to be the impact both on the people who are using it, but people who are not using it. For example, will it lead to job losses and things like that? So positive benefit and negative. So impact is it reduces the time required for creating, writing, and design. And if you go further down the road, that means the companies might not need as many people to do that job. So I mean that's I will talk about that in the last slide. Then you have Google's DeepMind, like Gemini AI is a like brand name that they are using. So it helps with AI assisted coding and research analysis. So again, what is the impact? The right away impact is it automates that task. But then if you go deeper, what does it mean? It means that you won't need as many people. All the benefit might be that things that will require manual intervention will not be requiring manual intervention anymore. So that's the benefit, that you will have less possibility of like people getting blind spot or having these errors. So that kind of things that are positive, and then you have negative impact on job prospects. Then NVIDIA has their own models. So they are using it for generating 3D words that could be used in games and metaverse applications. Healthcare, so I mean medical imaging, you just saw the presentation, is also used in AI drug discovery. So they can predict the molecular structure and work around with different types of proteins to develop new medicine. The impact is it reduces the time needed for drug development. In finance, is being used for fraud detection and risk assessment, right? So you have a whole, so it started with pattern matching, etc. But now you can use these fancy models where the data doesn't even have to be similar to the previous data. It can actually improve the predictive power of finding out whether a particular fraud or transaction is likely to be a fraud and that kind of thing. So what are some of the future trends? First one is, again, rather than just doing one thing, you can either, right now, most of the applications either develop image or text or audio. Now you can develop multiple things with the same model. So GPT-4 has that within Google's Gemini. So in applications for each of them, you can have AI-powered assistant that like understands everything, and then you can generate them across multiple type of data sources, and you can generate different type of output. Then the other major trend is people are going to use it for, or companies are going to use it for generating the code itself. So AI-driven software development. And this is something that worries like a lot of policymakers as well, that at least in the beginning when you're writing, I mean, at least right now, you're writing these AI codes, there's a human involved. But if the code generation itself happens through AI, what would happen? You won't even have an say in how to improve or what's happening with these models. So AI models writing AI improvement code and that kind of possibilities. Right? And you have seen that in science fiction. But right now, we are not there yet. But I mean, that's the actual theoretical possibility. It's AI-driven software development. So the repetitive coding tasks can be basically replaced by AI models. Then you have real-time generative AI, where like you have seen the example in chatbots where you don't even know whether the queries that are being answered by a person or a chat, basically a character, right? In this case, in video games, there's an example, but you also have that example in there are a couple of applications where these models have been deployed to provide a virtual customer representative. And you have personalized AI. That's another trend that is going to come. So you will replace executive assistants. For example, there's a talk about that creating these dedicated models where somebody learns about your whole schedule as an executive. It knows what you do. It reads your email, and it can actually find out not only how you write an email, but also what kind of things you like to do. And then it can suggest to you that, okay, you like this kind of food. Do you want to make a reservation there? So personalized AI. And then the main thing that I like me and many other researchers and standard developers are working on is how to make sure that this AI sector is regulated and ethical considerations are not dropped because of profit making motives. So new laws and policies around AI generated content. Deep fake is another concern that, okay, for example, social media is now powerful in affecting the election outcomes. And there was an inquiry, even though it was not related to AI, but the role of social media. But if you combine that with generation of deep fakes, then it becomes more important because the elections and your own, like who is going to regulate the sector might be affected by AI generated content. That's another concern. So, I mean, this like, what are some of the challenges in generative AI adoptions? So one is again high computational cost, and this is why you don't see those many models coming from developing countries, right? You have like US dominating, even Europe doesn't have like this kind of like big scale models because there's a high computational cost. The second one is data privacy and security concern. Right? So if you are really worried about that sensitive data can lead to privacy breaches, you will be careful, and then it will take more time for you to adopt. And this is why, right, there are some techniques that you have to, basically you can take the personally identified data out, or you can have learning done there, and then while making inference, you don't use that data, that kind of thing you can do. Then ethical and bias challenges, we talked about it, right? AI generated content can reinforce the biases. And this is why the adoption in industries where these biases matters will be slow or will be more controlled until we find bias mitigation strategies. Then the third or like fourth point is this hallucination and reliability issues. So data can, like generative AI models can start generating facts that don't exist. That's actually a feature of, because it's just a probability distribution. It can so happen that you are selecting for a given prompt, generating something that's actually misleading. And then like integration with legacy system. So one of the problems will be that you don't want to give up everything just because you want to adopt or build a new AI model. It has to integrate work with the existing workflow. So that might be one of the concerns in adoption. So that's all very well. I mean, how do you do like build your own model if you have to do it? So I already outlined the steps, and these days there are tools that exist, and with a little bit of setup on cloud, you can actually try your own hands on the building your own model. So you select like these are some of the steps, and I will talk about these tools very quickly. These are the popular tools. One of the open models you can use. Select a pre-trained model. You don't have to get the data and build up the whole infrastructure. Use a pre-trained model. Set up a development environment, right? For example, Python-based framework you can use. You can use these tools, Jupyter Notebook or Google. Then you just fine tune. So let's say you have like, for example, you're creating a model that is fine tuned to use only a particular set of papers in a particular field. I'm just giving an example, right? So then you can fine tune a chatbot for academic support. So it could be just an experiment that you want to perform. And then once it is fine tuned, then you can deploy it. So you, right, rather than buying a machine, you can try with one of the these cloud accounts, and some of them give free like $100 per month credits. So that should be good enough for trying your hands out. And if you have a non-profit, like for example, .edu or .ac.in account, you might have free tier access to this cloud environment, and there you can deploy it. For example, you can create your own AI-based generator. So, I mean, now I'll talk about things that you might already know, like some of the open source tools and these resources for building your own model. So you can use one of the open source AI frameworks like Hugging Face. You have Stable Diffusion if you want to work in image, Whisper AI. So when if like let's say you don't have money or resources to pay for API calls to OpenAI, right? So you still have open source frameworks where you don't even have to pay anything. For model training, you have TensorFlow and PyTorch. These are most popular libraries or frameworks. Right? For then the next part is you basically manipulate or fine tune it by find out what are the biases. If they already know, then you perform experiment using the tools that exist to do experiments, whether it works fine or not. And then you can have yourself or some of your end users, like beta users, help you train that model. And then if you want a database for training and fine tuning, there are some options available. Like you have Common Crawl, ImageNet if you're working with an image model, right? And then for multi-models, there are a couple of databases. I mentioned one here, 5 billion data. Then there are Hugging Face has a library or the marketplace where you can actually find out pre-trained models for NLP and vision. So there's a marketplace. I mean, this called Hugging Face Model Hub. There you can find out some models. Right? Google already has few models. BERT was the model that they released even before OpenAI came in. But now you have better models that and you are free to use all these without paying. So I'll talk about again, I mean, it might be a recap for many of you who have used it, but it's good to know. So these are some of the tools, right? What is ChatGPT, OpenAI model? The data that was used for training is books, articles, and this is what is important when you are using it. You should know where the data came from so that you know what kind of biases it might have or what kind of weaknesses it might have. And this is why, I mean, as a practitioner, knowing how a model is trained, how it's deployed, even if you're not building your own, you might benefit from it by knowing how to use it. It's just like any other tool. So it was fine-tuned with reinforcement learning, but human feedback. And this is the example I gave. They used a company that helped them connect with people in India, Bangladesh, and all these developing countries for a fraction of a cost to help them fine-tune that model. So what are the key capabilities? It has context-aware conversations. So for each of the user, it saves some history, and then it responds in human-like dialogue. And you can have image interpretation as well and code assistance. So they are adding all these new functionality, but their original use case was how to chatbot. So now they're what you can use it for as a practitioner. If you're building your own model, you can use it for any of the chatbots for a particular sector, or you can have tutors or research assistant if you're working in academics, right? You can write blogs, product this thing. So that's one use case. Then you have another very popular tool for image, Midjourney. So again, the data used was mix of publicly available art, license engine, community feedback. So they also used humans in training. And again, it's trained for artistic style and concept design. So you will not, and this is why some of the images that you see they look unrealistic because they are trained using art data. So this is something that you might find useful if you learn more about how the data that was used to train it was obtained. Then you will know what kind of uh, capabilities it has and what should you use it for. So everything is related. So for example, it can produce very realistic artistic image. You can modify the themes because it knows about different themes. And what are the use cases? You can use it to generate brands, ads, that you are using it in game and film production. Social media, you can use it for generating personalized avatar or creating materials for your own websites. So the other tool, again, it's very popular. I'm just giving examples, like which some of the popular tools. So this one is AI coding assistant. Microsoft, they bought GitHub and now they have released it. So the data that was used from the, right, it was derived from the model is used, it's called Codex, it's derived from GPT, they built it. But the training data that was used was GitHub repository, publicly available. And then they again used like developer feedback. So most of the models so far have used human in the loop for training because they want to make sure that the data that is coming out is actually relevant to humans. And what are the capabilities? You can do real-time code completion. So if you give it like a outline, if you have a function signature, it can complete, or it can even write the entire function. It supports multiple language. One of the more important feature is bug fixing. So if you give it a code, it try to find out what is the like what can go wrong. Is there a bug in there? And find out. And then other way around, you can type text and it can try to find identify what is the error, where is the error coming from, and what are the use cases. Again, most of the use cases you can see are either in productivity, it makes the existing person more productive, and this is what it's being sold as. But as a result, that means you won't need as many people, and this is where like the trade-off comes into picture. That okay, I mean, how much should you use it for and what purpose? And this is why the role of policymakers. The second use case is, of course, education and learning. So it can explain things that, okay, why this code block is written this way. Can you improve it, right? So it can help the student understand complex tasks and low code development. And this is good for, let's say you are not an expert, you can type something that this is what I'm looking for. It will generate a function for you for simple applications. Then you have, this is something that's like Google keeps changing, but right now they're calling it like using DeepMind model. Like they are using a brand name called Notebook LM. They released it last year. And for document analysis, and you can summarize, let's say you have 1,000 PDFs, it can actually summarize, you can upload it and it will summarize it for you. So the data that was used was Gemini. Before that, it was called Bard. So most of it's trained using research papers and academic content. And Google created a knowledge graph. So they took a different approach. Rather than just generating text in the beginning, Google tried to identify concepts. And they created these knowledge graphs. And then this is why, I mean, if you want to play around with, this could be a good model, especially given that it's trained using research papers. And it allows you to upload your own PDFs and fine tune the model and train it. And what are the capabilities? It can extract insights from PDFs. It can summarize and explain things. So let's say you have a query that, okay, according to experts, does this work? Or according to expert, is this good or bad? So then it will read it and will summarize that majority of people think this way, but there has been evidence that, so that kind of explanation, and this thing is possible. Context-aware research companion. What are the use cases? It helps researchers find out, like you can perform literature review. So if you have access to a whole folder of PDF files, and especially if you're working in an environment where a lot of people collaborate, you can talk to the department and find out that is it possibility that everybody just puts the scientific papers in one library. If it is tagged, it's better. Even if it is not tagged, you can actually have that whole data structure or data set to create your own internal tool where all the future researchers or your postdocs can actually find out, rather than spending time on Google Scholar reading through, finding the appropriate query. You can use these tools. And there are many universities who are building internal tools like that. So study companion for students, right? You can summarize. Even for business, you have use case of. I gave example of McKinsey. They are building their own tools. Then Facebook or Meta AI, they also came up with this speech and audio. Right? So their model was like they used to call it seamless M40, multimodal machine translation model. So the training data, so they use publicly available. So one of the most important thing to notice that many of them are using public available data because they realize that if the predictions are coming on later on, they might need to explain why it's coming. So publicly available data helps them track and make it easier to explain why something is being inferred or these kind of things. So when you are building your own model, these are the considerations that you have to keep in mind. First of all, is it going to be biased if I use the data source that's not public, that's not authenticated? Right? It's just like a peer review paper versus a magazine articles. These kind of things that you have to like consider. And again, for it's been